All right. Should we start? Let's give it a go. Please take your seats. Jack? Thank you. Well, welcome everyone, and hello and salam alaikum to everyone. Welcome to the first conference of its kind, ArabicNLP. We graduated from WANLP, as you guys know. So this is our first conference. My name is Hassan Sawaf. I was chosen to be chair for this year from the SIG Arab community. So we're gonna go through a few introductory slides. So first of all, it would be great if we basically all actively showed the participation, the content which we have by, for example, co-referencing Twitter or what is called now X, and you see the handle here, and use the following hashtags: ArabicNLP, ArabicNLP 2023, and EMNLP, as we are co-located with EMNLP. Just to give you like a little picture of what the journey was, where we are, why we are here, where we are. So we started in 2014 with WANLP as the first conference, and then the 7th was just last year. Remind me, where was it? Last year was in Abu Dhabi. Yes, Abu Dhabi, exactly right. And now we are in Singapore. And this is the first conference. So we converted the workshop into a conference, which shows also where we are in terms of like in double quotes growing up, which as a conference, which is great. So yeah, I mean the handle, as you can see here, in 2020. I mean we started. Did we use this handle already in 2020? Is that what this? We changed it later to this. Okay, so that's the handle of today, which used to be a different one earlier before that. And remind me what this SIG Arab? SIG Arab was actually from the beginning, right? No, SIG Arab. Oh, that's right. We are officially now a SIG Arab since 2020. That's what it is. What I'm actually quite happy about is we have 250 registrants this year, which is quite a few. I mean, compared to our past. I'm gonna hand over now to Walid to continue the details about it.
So, assalamu alaikum, everyone. So welcome again to the first ArabicNLP conference. Now, as you see, so I'm Walid Magdy. I served as one of the PC chairs for the first occurrence of the conference. And it was actually with Wajdi, who was the second person, and Samha, who couldn't attend, unfortunately. But we worked this year to actually work on the submissions and the review process and everything. And I'd like to share with you some statistics about what we received this year. So actually, for the main conference itself, we received, I think, the largest number of submissions compared to all the workshops happened before. So we received 80 submissions for the main conference itself. And we were targeting actually to get an acceptance rate around 40%, but it ended up actually that we found really many good submissions, and the reviewers were so happy with many submissions. So we ended up accepting 38 submissions in total, 32 long papers and 6 short papers, 2 of which actually were submitted as long but accepted as short. So in total, we have 38 papers. But this is only just for the main conference, the main conference papers. However, again, for the first time, we have large number of shared tasks that has been organized this year. So we have 5 shared tasks. I think many of you already participated in them. And this is actually, so we still have 5 overview papers which describe actually the task itself and what happened in them, and another 48 system description papers. So when you come to the total size of our proceedings, we are talking about 91 papers in the proceedings, which is compared to, I think, the largest we had before, I think it was 65. Now we are growing so fast, which makes sense now that we are a conference. And this is actually the statistics about the submissions we had. What about the program today? So we start by this welcome speech, which hopefully would finish in 10 minutes. And then we will have a set of 7 talks after this one directly. It's about the Arabic downstream NLP tasks. After that, we will have a coffee break for 30 minutes. Then another session, an hour and a half that we need to accommodate 9 talks in it, which will be about the main topic everyone is talking about in NLP community now, large language models and their applications. Then we'll have our lunch break. Afterwards, we'll have 2 talks, additional talks about long papers. By the way, the talks are all for long papers only. We couldn't accommodate, unfortunately, short papers for talks. Even not all the long papers are in-person talks. Then afterwards, we will have a very short talks by our organizers for the shared tasks. Each is around 5 minutes. And after that, we will have a very interesting panel discussion led by the moderator will be Mona, and we'll have our members Karim, Prislav, and Arib will be actually in the session to talk about the larger language models, the challenges and actually opportunities for the Arabic language. Afterwards, we'll have another coffee break. Then we will have at 4 p.m. we'll have 2 sessions in parallel. One in person here for the poster session, and it will be downstairs in B1. Large number of posters will be there. It will be mainly for the short papers, for the remaining long papers, and for the shared task papers. And we will have at the same time an online session for those who couldn't attend. So please, if you can attend both, it would be great. So check the posters and go online to actually see what people are doing. Some logistics. You can see we have a very tight schedule. It's a large number of papers. We didn't expect this large number of papers to be there in the conference in the first occurrence, which is good, alhamdulillah. So it's a very tight schedule. So for the speakers, we kindly ask them to stick to their time. The presentation is only 8 minutes. Our chairs will be stopping you after 8 minutes. And please, if you didn't send your slides yet, please send it to this following email. If you are presenting, please send your slides directly to this email, administrator@underline.io, so it will be ready on the machine to present it. And please, for the audience, after each presentation, we will give the chance for 1 or 2 questions at most. If you have longer discussion, if you have more questions, save it for the coffee breaks, because we have other talks to present. And as I mentioned, in the poster session and online session, they will be in parallel, so try to be actually checking both. One additional thing to discuss is actually the PISTA Paper Award. So we received actually very good quality papers this year. And there have been a discussion between the organizers and the PC chairs about which should be the best paper submitted to the conference. And it ended up actually like a big discussion about specifically 2 papers. And it ended up that we selected one of them to be the best paper. However, we decided to show the other one as the runner-up, because they are not the best paper, but we're actually very close to be the best paper, so they can mention it in the future. So the runner-up paper for the best paper award actually is this paper, Lance, Large Scale Arabic News Summarization and Corpus. They are presenting online, so actually you might be interested to go and see them. Unfortunately, they are not here. But the winner for the best paper award is... it's actually ARTEST, Arabic Text and Speech Transformer. And I think the authors are coming from MBZ EU for AI. So it's actually congratulations for them. And if any of them is around, please. I think they are presenting in the second session, so you should be there. We'll try to print it and give you something physical. So this is actually for the Best Paper Award. Before I go, we have some acknowledgements we have to say, because this actually has been a large amount of work that everyone has worked together to try to make it successful. Hopefully, by the end of the day, even the organization and presentations will go fine as well. So first of all, we have to thank the PC committee actually who participated in reviewing our papers. We never expected this large amount of submissions. You're talking about in total, we will have over 140 papers between the main conference and the workshop and the shared tasks. So we have a large review process that we had. However, of course, sometimes that not everyone managed to submit their reviews on time. So we ask it for the Ninja reviewers, and we thank them so much because they saved the day in the last couple of 2-3 days. We managed to get actually the remaining reviews to be submitted. So we thank them so much. We should actually also thank the shared task organizers, because actually you enriched this event a lot by actually having these challenging NLP tasks in Arabic to be done. Of course, we should thank the participants. We are actually happy with 260 registrants. Not all of them are in person, but I think it will be more people will be joining now. I know that with the jet lag, not everyone will be coming early morning. And of course, the organizers. This actually is not just the general chair and the PC chairs. They're actually the publication chairs. They did a lot of work. Ahmed Abdul-Ali and Nadi. I'm not sure if he joined here yet, but we were expecting, as every year, some papers to be in the proceedings. We found a lot of papers, a lot of problems, a lot of formats. Some actually at the last moment we found that one of the papers missing the authors' names. So these kind of things, that a lot of work has been done. And also, of course, the publicity chairs, the shared task chair, and everyone. But actually, I'm adding one special thanks here for, and it has to be mentioned, because this actually comes for the person that his name is not listed even on the website. It's actually Nizar. So Nizar, actually, just to mention, and beside actually running SIG Arab and taking care of that, he has been attending all the meetings for the organizer every week, while he's not mentioned on the website. And when we're talking about Ninja reviewers, every time I ask, we need reviewers, he go, okay, give me a paper, give me a paper. So he ended up actually reviewing 7 papers, the largest number of papers anyone did. And even I think that you heard about the bad news about losing some of his family. He still attended a meeting a few hours after that to be with us. So really, we cannot thank you about all the work you did. And now actually, we should actually give it to Nizar himself to talk about the SIG Arab report. Thank you.
Thanks, everybody. Very happy to be here. So State of SIG Arab. So I'll speak as the president of SIG Arab. So some of you may not know what that is, just to explain. So a SIG is a special interest group. Within the Association for Computational Linguistics, we have many different special interest groups. Some of them are extremely large, like SIGDAT, that actually runs the EMNLP conference, and some are very small. And we were actually non-existing before as a SIG, which meant we couldn't have the ability to collect sponsorship, bank from year to year, and get a lot of additional privileges organizationally. So in 2022, after many years of being part of this community, we decided to do the jump. And thank you all for your support. All the people who signed up basically helped us make the argument that we should be treated as SIG. And right now, we're actually quite large. I cannot see the slides here very well. Yeah, so we'll be celebrating our 2-year birthday in about a month or so. January 20th is our birthday as a SIG. We have over 800 members already, which is incredible, actually, when you think about it. If you're not a member or you're not on the mailing list, go to www.sigarab.org. Join the SIG and also join the mailing list. You don't have to actually be on both, but we encourage you to be on both to be up to date on all of the conversations going on. The mailing list has been very enriching. I mean, I've been in this field for a long time, and I'm learning new things from all the people who are doing wonderful things and sharing with each other. So keep talking and keep sharing. See, of course, I have to thank all the sponsors, who basically were provided us for the first time. I mean, the large amount of sponsorship we've ever received in our history. Admittedly, short history, but still, it's quite impressive. We can only go hopefully upward from there. So thanks to مجمع الملك سلمان العالمي للغة العربية, to AI Explain, thanks to Lisan, to Sky, which is the Saudi company for AI, Majarra, which, if you don't know, is a major news agency company in the UAE, and then Big IR, which is one of the shared task leaders running the one of the shared tasks here. I think it is the Quran QA was the shared task. So the money that came were used for awards for the shared task, if it was dedicated for that, and also for scholarships for mostly virtual attendance or supporting in-person attendance with the amount of virtual. Okay, we got enough money, but we didn't get a lot of money. If you have connections, please send them our way next year so we become, a rich SIG. But about 100 or so applications were submitted, which was surprising. I think last year we had some 30-something requests. This year we offered 30, I think 33 or 34 at the end. And in terms of where we're going next year, so there will be 2 events connected to SIG Arab in 2024. It's very exciting. One is the second ArabicNLP conference, which will be held in Bangkok in Thailand with ACL. And the other one is the OSAC workshop, Open Source Arabic Corpora and Tools, I think that's something like this. Sorry. This will be in Koling, I believe, in May. So LREC Koling, which will be held together this year. So see you there. Lots of opportunity to submit good papers and share what you're doing with the rest of the community. And I will stop now so that we can start the program. Thank you.
Okay. Starting with the first doc. Who's the first doc?
All right, so I'm just going to jump in as in minutes, of course, as you know. So our first speaker is Menna Fateen, talking about in-context meta-learning versus semantic score-based similarity.
This is a PDF. It's not a PowerPoint.
And thanks to our volunteers who are working very hard under some.
That's the one thing. Not helping. Okay. I'm not sure if I'm this full screen. Is that okay? Yeah.
All right.
Okay.
Great. So Menna, please just jump in.
Okay. Okay, hello everyone. My name is Menna Fateen. I'm a PhD student at Kyushu University, Japan. My supervisor is Professor Tsunenori, and I'm here to present our work titled In Context Middle Learning versus Semantic Score-Based Similarity, a Comparative Study in Arabic Short Answer Grading. Phew. So that was a mouthful. I'm gonna give a background on the last few words here, short answer grading. So automatic short answer grading has been a prominent subject of research in educational data mining. It's been explored for over 50 years because it offers great potential for educational enhancement. To be more specific, the benefits of automatic short answer grading include the automation of routine grading tasks, reducing scoring turnaround time and also costs. And this enhances efficiency of teachers and leaves them with more time to focus on their human role as motivators and nurturers of learning. So automatic short answer grading systems can be classified into belonging to one of these two main paradigms, instance-based systems and reference-based. So instance-based systems, we have student answers that we extract features from these answers to an embedding, and the model learns about the properties of correct versus incorrect answers from the training distribution. In reference-based systems, we extract the features from both a student answer and a reference answer, and we then compare these two embeddings and score it. So these reference-based systems offer an advantage of interpretability and being less data hungry. So our main research questions, the first one, so basically we have, we want to compare state-of-the-art instance-based approach with a reference-based approach, and we want to compare these two systems in conventional training settings where we have unseen answers. In our second scenario, we have zero-shot settings or unseen questions. So the data set that we utilized as the first publicly available data set, which is the ARASAG data set. It includes 2,133 short answers, and these questions are 48 questions, and they're classified into 5 main prompt types or categories. So the models and the methodology. So our instance-based approach is what we call in-context middle learning. As you can see here in this diagram, the first step is we construct an in-context template for the answers. So we first concatenate the answer with a semantically meaningful task instruction, such as score this answer. We then also add the question and the reference answer, and also include some in-context examples. And then we train ArabBERT on the data set for each prompt category. And yeah, the next approach is our reference-based approach. So in this model, our score-based semantic similarity model, we construct an in-context template by prepending the question to the answer. And this has been shown to improve the performance. And then we generate input pairs to construct the data set by adding a similarity measure. So the similarity measure between the similarity between two answers, AX and AY, is defined as the ratio between their scores. And the data set is constructed using this equation. And then we fine-tune ArabBERT on this data set by using a cosine similarity-based loss function. And during inference time, we can then input both the student answer and the reference answer, and then get the embeddings and find the similarity between these two embeddings to get the final score. So for both approaches, we trained one model per prompt category. So we have 5 main models for each approach. So in order to facilitate the choice of the model, we use a prompt category classifier. And we used a sentence transformer-based model, and our initial results were very poor, mainly due to the low number of training examples. So we augmented the data using GPT 3.5, and we can see that there was a very significant increase in performance. So moving on to the results of the comparison. I'm going to show the evaluation metrics. So we have PTA, or percentage of tick accuracy. This metric measures the percentage of answers that are scored correctly or within X points of the gold score. So basically PTA 0 is equivalent to accuracy, while PTA 1 would also include scores that are 1 point away from the gold score. And then we have QWK, or quadratic weighted kappa, which is a commonly used metric in automatic short answer grading, which measures the agreement between two raters. We established two main baselines, the majority vote classifier and the QWK between the human graders. So in our unseen answers scenario, we see that, there are a lot of results, but because we have one model per prompt category, but to summarize, we have both approaches are mostly outperform the majority vote. And however, we can see that the in-context middle learning, or the instance-based approach, generally gives better performance compared to the reference-based approach. In the unseen questions, which is the zero-shot setting, we can clearly see a lower performance, which is expected, but we can see that the semantic similarity gives higher performance compared to the in-context middle learning, which showcases its reduced data hunger and its ability to generalize. So to wrap up, we have the unseen answer scenario. We see that both the instance-based approach and the reference-based approach were able to outperform the majority vote baseline, and we were also comparable to the human raters when grading unseen answers. While in the unseen question scenario, we observe a tendency for the reference-based approach to outperform instance-based. So to summarize, in classroom settings, we think that the reference-based, the semantic similarity-based model can be a more suitable solution due to its superiority. That's it. Thank you very much for listening.
Thank you. So, any questions?
Yeah, I'm sorry.
Can ask one while people are thinking. So, how many additional examples did you use for the GPT additional augmentation that gave you results?
Okay, so I have an extra slide for that. So we have 3 different settings we did for the augmentation. So augmentation 1, 2, 3, where we provided 45 examples per prompt, and then 125 and 250.
And why did you stop at that number? Why didn't you go further higher?
I think we just wanted to show that that was a good.
Did you do any sense of the kind of errors that you still have after that have not been resolved yet?
Well, since errors, maybe like the semantic similarity based model could be improved, I think. Time
to take it maybe to the break.
Yeah,
okay. No problem. Thank you very much. Thank you, Menna. Our next speakers are Amal, I believe, and Walid Magdy. Arabic dialect identification under scrutiny. It's a good title.
Also a PDF. It's a PDF, no?
Okay, so yeah. Hello, everyone. My name is Amr Kilic. I'm a PhD student at the University of Edinburgh, and I will be presenting our paper titled Arabic Dialect Identification Under Scrutiny, Limitations of Single Label Classification. And this work has been done under supervision of Walid Magdy. Okay, so let's start with an example of an Arabic sentence, which is شنو رقم الرحلة, which can be translated to what's the flight number. And if I ask you the following question, assuming you're a native Arabic speaker or you can speak Arabic, is this sentence actually valid in your native dialect? So maybe you can raise your hand if that's the case. Would you say such sentence actually? So yeah, I can see some. I don't really know what dialect you speak, but I can assume they are not really the same dialect, especially if you are saying it's on the country level dialect. But if I ask you a different question, which is what's the dialect of this sentence, there are actually two issues. The first is if it's not in your native dialect, sometimes it's hard to actually say it belongs to this country, at least for me as an Arabic speaker. And the other issue is what if it has multiple dialects that are actually valid for the sentence? You'll need to just pick one in the end. So it's kind of known within the community that the task of Arabic dialect identification is challenging. And the conclusions for most of the papers are we need better models, we need better data sets or larger ones. But what we are arguing for is we actually need a different setup, which is we need to move from single label classification to multiple label classification. So we have a couple of experiments in the paper to motivate this, but we'll just focus on one, which is analyzing the errors of an Arabic dialect identification system. So the system is built as follows. It's a BERT-based system. It's actually MARBERT, fine-tuned on NADI 2023's training dataset, which is a shared task that's actually being organized as part of this conference. And the dataset has 18 country-level dialects. The dataset is balanced across these dialects. So it has, as far as I remember, 1,000 samples for each country. So it's balanced across the countries. And for the testing dataset, we used Qadi's test set, which is having the same 18 country-level dialects. The samples are initially assigned to a specific dialect using geolocation, but then the dialects are actually validated by native speakers. So for instance, if we have 500 samples that are geolocated to be in Saudi Arabia, for instance, annotators from Saudi Arabia were asked to validate these labels, which makes quality of the labels maybe more trustable, the labels of the dataset. So the model achieves a macro F1 score of 0.51, and this is a confusion matrix for the predictions. So the rows and columns are actually sorted in kind of regions of Arabic dialects. And we will notice that actually within the same region, which are the parts shown in black squares, most of the errors are there, but still there are actually errors that are across different regions. So we decided to do an error analysis for 7 of these dialects. And the error analysis is as follows. So actually, these are the errors that the model make for samples that are not supposed to be in Egyptian Arabic, but the model is actually predicting them to be in Egyptian Arabic. So what we do in this case is we ask an Egyptian, are these sentences valid in your dialect or not, without actually telling them that they are initially labeled as being in different dialects. So I'll show 2 examples for this. The first is this one. Sorry, I can't actually see the slides on my screen, so I'll need to read it from here. So it's مرتضى صوته ضعيف مع كامل احترامي ما يتقارنش بنسيم مجرد مقارنة. So that's a sentence. And if we ask an Egyptian person, is this valid in your dialect? They can say, yes, I'm an Egyptian. I would say it's valid. So in this case, this is not an error, actually. It shouldn't be, the model shouldn't be penalized for making this prediction. And just for your information, the original label for this sample was Tunisian Arabic. If I show another sample, which is بجد الناس اللي بتنسى بسرعة بجد كيف تعملوها. As an Egyptian, I would say this is not really valid in my dialect. I won't say كيف تعملوها. So in this sense, this is an error and the model should be penalized for that. And also for your information, this is initially labeled as being in Algerian Arabic. So that's what we have done for the 7 dialects. And for the results, I'll show just 2 of them for 2 dialects. For Egyptian, only 26% of the errors are actually true errors, in the sense that most of the errors are valid in Egyptian Arabic according to the annotator. And for the majority, the model shouldn't be penalized for that. So that's basically a limitation of just saying there is a single label for each sample. Similarly, for Saudi Arabian Arabic, only 26.5% of the samples, and the errors that for which the model should be penalized are actually the red portions of the different bars. So these are the ones that a Saudi Arabian annotator would say is not valid in Saudi Arabian Arabic. So if we re-evaluate the system, which initially had an F1 score of 0.51, but only for these 7 dialects, and we recompute the values of true positives and false positives based on our analysis, we find that actually the same system would achieve macro F1 score of 0.72 compared to 0.56 for these 7 dialects before doing this recomputation. So there's a huge difference that can be achieved just by picking a different label for each sample over the other. And clearly there is nothing in the sentence that would say it should be in Tunisian Arabic and not Egyptian Arabic. They're both equally probable. So we propose multi-label classification, and there are lots of details in the papers, but the setup would be as follows. If we have n sentences, and instead of asking an Arabic annotator to determine all the dialects, we'll just ask them, is this valid in your dialect or not? So if we start with an Algerian annotator, the question is it valid in Algerian Arabic? And the answer is yes or not, or yes or no. And similarly for the different dialects, and that's how we can build a multi-label classification dataset. So that's generally it. I will just have a shameless plug for another paper you have in EMNLP, and I will actually be doing a poster presentation tomorrow and also today in ArabicNLP's conference poster session today. And that's introducing the concept of different levels of dialectness. So I'll just show 3 examples for this. These are 3 different versions of the same sentence, and the model is providing different scores for these sentences. For the sake of time, I won't really read them, but I can. I hope you can see the differences in the sentences and the differences in the scores of them. So yeah, that's it for me. Thank you.
Thanks, Amal.
Jack Halpern from the CJK Dictionary Institute. Thank you for the very interesting presentation. We just completed a very major dialect database of Egyptian and Emirati and Hijazi. And one of the problems that we find in the corpus, we use a social media corpus, is that, for example, in Egyptian Arabic, there are many words that are MSA, or there are words that are misspelled, or there are words which are not even Egyptian. So it's very difficult to actually determine. Well, we use frequency to some extent, but I wonder, what do you do? How do you get rid of the garbage, so to speak, the non-Egyptian Arabic, the MSA, and so on?
So yeah, I mean, I'm not sure if I would call it garbage. I guess that's one point we haven't really addressed in the paper, which is how to actually select the set of n sentences to annotate. So maybe if these n sentences are mainly MSAs, then you can maybe discard them. And actually for NADI, that's what's currently done. So they have initially tweets, they split them into MSA and not MSA, and then the shared task will only focus on the non-MSA ones. So I can see the point of MSA. For other words, I guess it's just how the annotator perceives the sentence as being in their dialect or not. So
very quick. Thank you for the presentation. So as far as the evaluation is concerned, even though there might be errors in the test set, but wouldn't it rank the systems appropriately as opposed to having like a gold standard?
I'm not sure. I was actually thinking about if we have the evaluation files for previous NADI sets, we can actually do this experiment and see if the ranks would change if we change the label. So that's a great, very good question. I mean, the system's predictions are online. I don't think they're publicly online, but yeah, we can discuss that.
Let's follow up with this afterwards. And thank you, Mohamad. If it's online, maybe a reminder to the community would be good. Yep. Thank you. All right. Next talk is Nâbra. It's you. Okay. So we have Mustafa Jarrad presenting. Bashar, you go ahead and set it up. Yeah. We're a bit late, unfortunately, and so Nâbra, Syrian, Arabic dialects with morphological annotations. While we're trying to figure this out, perhaps for people in the next talk sessions, come to Bashar, set things up during the break. It would be very helpful, I think.
Yeah, also, if you have your slides set up, just make sure to send them to administrator at underline.io. If you have any questions, just come over and see me so we can set it up beforehand.
Yeah, please do this during the break. Thanks.
This is it. Okay.
Okay, nice to be with you, and I will present our work on also on dialects. So following up the previous talk, so I will talk about the Syrian dialect. So you know, I come from Birzeit University in Palestine, Ramallah, not in Gaza, so a little easier. And we, our group is mainly concerned of developing natural language resources. I don't know this mouse.
Here we go. Yep.
Oh. Okay. Yeah. And so we develop a lot of resources, like we have a lexicographic database of 150 lexicons, and the Arabic WordNet and Arabic ontology. We have also a set of corpora that we developed for dialects and other things. So yeah, it have been covered maybe. So if you visit our website, this is the QR code for our resources. Then you can, if sina.birzeit.edu/resources, then you can see all of our resources. So this paper talks about the Syrian dialects, not only one dialect. So we did a set of the Syrian dialects. And you know, there are different kind of Arabic, and this work comes here. So first we did the Kurras Palestinian dialect, we did then the Lebanese dialect, and then we did actually Lisan. Lisan is a set of 4 dialects. Yemeni, Iraqi, Libyan, and Sudanese dialect. We did it with in collaboration with the UN and with the American University of Beirut. And we also now we came to present you the Syrian dialect. Actually, yesterday, no, the day before yesterday, I presented Lisan, and we get the best paper award in another conference. So, what do we mean with? Oh, sorry. What do we mean with? We did a dialect. يعني نقول حوسبنا اللهجة. What do we mean is actually is like this. We take away every word. So first we collect a corpus. Every word in this corpus, we first segment the word. We say these are the set of prefixes. This is the set of this stem, suffixes, and so on. As you see here, this is the word هيك. So هيك الواو حرف عطف. So this is the prefix and the type of the BOS of the prefixes can be more than one prefix. Then the stem, then the suffixes and their BOS. Then we have the BOS, and then we have the llama. So, and we have the gloss in English. Maybe you are, some of you are very familiar with this kind of annotations. So, but I see some people, when we say we annotated the corpus, they mean a sentence and we put a class. We are not talking about these kind of annotations. We are talking about morphological annotations. If you visit this site, you will actually see 1.3 million tokens annotated. As I told you here, with here. So the Palestinians 56,000 token, Lebanese 10, the Syrians is 60, and in total here we have about 1.25 million. So in total we have about 1.35 million tokens. This is really massive, and people who are familiar with this work can imagine how much every word takes time to do, and the accuracy is also so these are the Syrian dialects we did and their numbers. The Dimashqi is the Shami is actually more, we have 17 Shami here. So I cannot read in the laptop. Wait a second. Cannot use this mouse also. Anyway, so these are examples. Sorry. So how do we collect the data? We actually, it was social media and also poetry and Zajal and, you know, collections. So it was very hard to reach 60,000. But because we did more dialects, it became easier for me now. It's, you know, we know how to do it. So even some Palestinians were helping in the annotations because they know how to really do it, and if they don't know, they will ask somebody from Syria. Actually, Amal did most of it. And by the way, I'm also very proud that I did 1/4 of this myself. So the data annotation. I enjoyed it's sometimes when you have free time and you want to enjoy, you want to learn something outside the research, so you go and you annotate the data. So I enjoyed it. I will not talk much about the guidelines because it's clear, and so these are the statistics about the Inter-Annotator agreement, I believe. Yeah, and I think that's it I wanted to say, because I can have more questions. So in total, the Levantine corpus is 125,000 tokens. So together, there are a lot of lessons we learned, and we compared between the dialects. I will take the 2 minutes, just questions is better. Yeah, thank you.
Questions? I could have a question for you. So many times when people do collections of data for the dialect, there's this bias or tendency or maybe gravity pull toward what I would call al-ajib wal-gharib fi al-lahjat, meaning the strange and wild in the dialects. As in, when you think Halabi or Mardini or Minatake, you're thinking, what is the thing that is the most like that, as opposed to what do people actually speak, right? Because there's a difference, right? There's the marking aspect and there's the aspect that are not marked. I'm not making a call of judgment of what is good or bad necessarily, but I'm curious, what did you do? Were there decisions made of how to select the data, or were data excluded because it looks too hard to tell that it's from that place, or some other decision? Just how did you make the decision to select?
Yeah, it's actually it's Amal who did it. She is Syrian. I don't distinguish between Halabi and not Halabi, and well, Halabi maybe, but some dialects in Syria I don't really distinguish. But so Amal, she was careful in judging these things, nothing more.
But there was no like filtering step of saying this came from, let's say, a Halabi website, but it did not look Halabi enough.
It's dictionary, there is a poetry, there is, so that's
Okay.
in this local.
Got it. Like what they did with Karras, in fact, where
Yeah.
you also covered something.
I forget something to say.
Yeah, hi. How did you decide how many local dialects there are? So, for example, like two cities, the difference between their dialects can be just a handful of words instead of.
You know, these things I understand you. Actually, we face this problem between Palestinian and Lebanese even more. So it is not easy to decide. It's the way that sometimes you collect this book or this post about from this local area. You say it's this area. In Lebanese, we thought when they say ultilhin, that it's female. Actually, half of Palestine say use ultilhin. So from Nazareth, Nasra, to the north, it's all ultilhin. So it's like Lebanese. I even sent Qarit al-Ghajar, if you know. I sent a recording to my friend, the Lebanese, and he couldn't distinguish whether this is a Lebanese in the south or a Palestinian. So it's continuum. So there is no really way to really decide.
Thank you. And this links nicely to Amr's talk, in fact, of multi-dialect labeling,
Yeah,
multi-reference
it's
labeling.
continuous. Yeah.
The next, just to alert, who's the next speaker? Hanin, the paper. Oh, it's you. Okay.
Yeah, yeah.
Okay.
Yeah.
Great. Now, the magical transformation of Mustafa Jarrad into Mustafa Jarrad again. Thank you.
Yeah, yeah. So just to tell you, I forget actually to say, there is a tool that we developed that if you want to digitize annotate a dialect, it's so smart, it's so handy. I mean, I spent many years developing this tool, so it's good. If you want, we can share it. So you help me with the So now I will switch. I can take time. I will switch to talk about named entity recognition. So you know, maybe you heard about Wujud. Wujud is a corpus for named entity recognition. Fine grain. Where is it? Yeah, this one. So fine grain. Oh, good. Fine grain. Okay, yeah. This is the one. Yeah. Okay. So Hanin is actually my master student, and also we did this work with Mohamad Abdul-Mageed and Ahmed. Ahmed is here, by the way. No. Okay. Okay. Good. It's working.
No, the online people cannot see this slide.
Okay.
This is it, right?
Yeah, yeah. So what we did actually, so first, what is Wujud? Wujud is a large corpus, about 500,000 tokens, annotated with nested named entities, nested. So when we say Edward Said Foundation, Edward Said Foundation is an organization, and Edward Said, which is a sub-text, is considered person. So that's wujud. So we went another level, basically, and we did it with fine grain, more. So again, this is, you can scan this in all my presentations. I showed this to show you where is it in the resources, where you can find it, and you can try download. It's all open source. So extended wujud, we call it wujud fine. So wujud fine is an extension to wujud. Okay. So what we did, we say subtypes. So I don't want to say, for example, Birzeit University is an organization. No, I need to know what type of organization is this. So this is some examples. Niamey is a capital of Nigeria. So in wujud, we say this is GBE. GBE means geopolitical entity. Okay. And also to align with the Algerians' priorities in the region. So we also call it GBE. So now we came to say, okay, but this is a country. Nigeria is a country. So we want to know not only that it is geopolitical entity, we want to know that it's a country. And that this is actually, it's also GBE, but it's an organization. Here we are talking in Nigeria, the government, not a Nigeria, the country. So this is example. Another example is a picture of some patients at Al-Shifa Hospital. So it's an organization. Al-Shifa Hospital is an organization. Or you can call it also a facility. But here, organization. So what we did, we say it is the facility of the organization, basically. Another example, I live northeast of Gaza City. So this is nested. Please notice that Gaza City itself is a GBE. Northwest of Gaza City is a location together. So now with the wujud fine, what we did, we say, okay, that one is town. This one is a region general, and so on. This is another example. Birzeit University announces a set of scholarships for PhD students. So Birzeit, by the way, Birzeit is a town in Palestine, if you don't know. Very nice town. So Birzeit is a GBE, but it's also a town. Birzeit University is an organization that is also a education. Okay, I will come to this, but so this is the tree we did. We took only 4 types of name entities, and we classified them into more types of entities. By the way, these entities are from the ACE corpus developed by LDC, but we enhanced it. We think we made some changes. So coming back, so before annotating with subtypes, we had to change the wujud guidelines because to make it compatible. By the way, just to open the bracket, forget my presentation. I can see a research problem, a nice research problem in the named entity recognition area, which is compatibility of guidelines. This is a data engineering problem, not a natural language processing problem, but it should be really solved because all guidelines are not compatible. But that's another thing. Now, so these are statistics about the number of entities we revised before annotating with subtypes. Okay, these are the guidelines of the subtypes. You can look at the paper. And then we trained a model. We trained actually 3. First, I was planning to be early, but it's okay. So we developed, we used different pre-trained models, but we first trained on flat without subtypes. Then we trained with nested without subtypes. Then we trained nested and subtypes. And as you see here, so it's 88% accuracy. I cannot use the mouse. Oh, okay. 88.5% accuracy or F1 score what we did. We did something actually a little more. We collected 3 domains out of, so we did an out of domain experiment, not seen at all this data. We collect just a small data set for testing. We collected from Al Jazeera about politics and another science and finance. And you see the model, actually, this is a limitation. The model is really has a low numbers, especially in science domain. And I think this is a problem in most of the, all of these deep learning models, just to show it. Again, you can try, download, and see all subtypes and everything from this link. It's all in GitHub and Hugging Face, all models, everything we have is open. Thank you.
Time for one question, please.
Okay, just quickly, the CJK Dictionary Institute, we specialize in Chinese and Japanese entity recognition. And I want to ask a question. What we found the most difficult of all is what's called POI, points of interest, not towns, but things like the names of squares, the names of hotels, the kind of things that a tourist would find on a map. We found it very difficult to identify them and to translate them into other languages. Have you had any issues with this, with POI? Is that one of your categories? Has it been included in your research?
So I will generalize your question, if you allow me, to say, what's the difference between named entity recognition in English and in Arabic in this deep learning era? It's actually, I think in Arabic is more challenging because it's difficult because there is no capitalization, there's names can be adjectives and so on. I don't know in Chinese, I cannot answer you, but in Arabic and in English, so it's language specific, I would say. That's all I can say. I cannot answer you regarding Chinese.
All right, I think we should move to the next speakers. We're really almost 10 minutes behind. Thank you, Mustafa. Next speaker is Nâbra Khabeer, cross-dialectal named entity recognition in Arabic.
Hi everyone. So my name is Nâbra. I am a PhD student at Université Sorbonne Paris Nord. I will be presenting my work on the work of our team on cross-dialect named entity recognition in Arabic. So the task of named entity recognition consists on identifying and classifying entities into predefined categories such as people, organization, locations, and more. And our objective in this work was to explore and study the transferability of named entity recognition models across Arabic dialects. So, of course, there are some challenges. The most important one is that we have on a side an abundance of datasets for modern standard Arabic, such as ANERCORP, ACMAR, AC, Wujud, and on the other side, we have scarcity and limited resources for dialect datasets. Also with varying annotation protocols. So in this work, we aim to bridge the gap between modern standard Arabic and dialectal Arabic. So our methodology was to first start by manually annotating dialectal named entity recognition datasets, then train a state-of-the-art model on already existing modern standard Arabic data, and finally test it on dialects to explore how well it transfers. Of course, on the whole process, we will be evaluating with different pre-trained language models. So for the dataset construction, for the modern standard Arabic data, we extracted it from the AC corpus. It was already annotated. And for the dialects, we annotated for Moroccan, Egyptian, and Syrian. We sourced the data from the XP3X corpus, and we followed the LDC guidelines, which are the guidelines that has been used for annotating the AC corpus. On the right, we have the statistics of our datasets, which we annotated for 7 entity types: person, facility, location, etc. So for the model architecture, we used a span-based model that we have developed earlier. We choose this model because it shows strong performance on named entity recognition benchmarks, and it also secured the winning solution at the Wujud shared task. You will be welcome to see and discuss about this in the poster sessions. So the model consists on enumerating and classifying all possible span in the sentence up to a fixed length. We train maximizing the likelihood of the goal spans, and for the inference, we use a global decoding model that maximizes the score while respecting non-overlapping constraints. So for the experiment, we tested with 2 settings. We trained on modern standard Arabic, and we tested on dialect. And also we did the opposite. We trained on dialects and tested on modern standard Arabic. For the different pre-trained language models, we used for modern standard Arabic, Camembert, MSA, and Arabert V2. For the dialect pre-trained language model, we used Camembert VA and Marbert V2. We also used the pre-trained language model trained on a mixture of modern standard Arabic and dialects, Camembert mix and Arabert V2. And we also tested with a multilingual pre-trained language model, MBERT and MDBERTA. So these are the main results of our experiments. So on the lines, we have the trained dataset, and on the columns, we have the test dataset. So we can observe that the most performing experiment is, of course, training with modern standard Arabic and testing on modern standard Arabic. Then for the 2 settings, which are training on modern standard Arabic and testing on dialects, or the opposite, we found that Syrian always yields the best performance, meaning the best transfer of the task is found when we go from modern standard Arabic to Syrian, or from Syrian to modern standard Arabic, and the worst is when going from modern standard Arabic to Moroccan, or from Moroccan to modern standard Arabic. The results were a little bit expected because we already know that linguistically modern standard Arabic, Syrian is the nearest to modern standard Arabic, and Moroccan is the farthest from modern standard Arabic. This is a little recap of the results. So as we seen, the modern standard Arabic to modern standard Arabic experiment achieved the best performance across all pre-trained language models. And here we have the tables for the best model when training on modern standard Arabic or on dialects. Last experiment, we wanted to study the impact on training on a mixture of Arabic dialects. So we found on the right column we have the results of the best trained dialect when testing on modern standard Arabic, and the middle column is when testing with mixtures, and we found out that training on the mixture consistently yields better performance when compared to training on single dialect over all the pre-trained language models. That's all. Thank you for your attention.
Nice.
I'm not going to. So actually, can you go back to the previous slide? So basically, is it because you're adding extra dialects or because you're adding more data? Because it could be that you just, when you mix them, you're actually getting a lot more data. That's why you're doing better at the end. That's my first question. And my second question is there are actually data sets from Yassine and from my team also on dialectal NER. I know they don't have the same labels. I mean, can you foresee how? I mean, this is the same problem that Mustafa was talking about, is the compatibility between data sets. Do you think you could have used them somehow? And on a completely side note, I didn't realize Syrian was the most closest to
Okay, so maybe. So maybe I will start answering the second question, which is how do we handle the problem of new labels, if I understood well. So the thing is, we followed the AC guidelines, and at first we wanted to add a label, a category for all other entities, but it was very complicated, so we just we decided to stick with the labels of the LDC guideline. For the first question, actually we tested with more modern standard Arabic data, and it doesn't improve the performance. We still don't have a clear explanation, but maybe it's because of overfitting. We will. This is a preliminary study. We will extend it to more dialects, and we will investigate more.
Thank you, Nâbra. Of course, the other question should be answered during the coffee break while your mouth is full eating other things. Okay, so our next speaker is, sorry, Vera Pavlova, leveraging domain adaptation and data augmentation to improve Qur'anic IR in English and Arabic.
Salam and welcome everyone. So my name is Vera. I'm from Rati Labs. Today I present our work leveraging domain adaptation and data augmentation to improve Qur'anic IR in English and Arabic. So we are dealing with domain-specific information retrieval. So ideally, what we would like to have is domain-specific language model and train it on a large amount of in-domain data. But what we normally have is That's ideal scenario, but what we normally have is general domain language model, and we have to train it on out of domain data. So we would like to move from real world setting to ideal scenario. So without putting too much compute power, what we can do is use domain adaptation and data augmentation. So in case of Islamic domain, we are dealing with a bit unusual situation because normally English as a high resource language offers a lot of language models in different domains, a lot of corpora. But in Islamic domain, Arabic is in more favorable conditions. There are language models available for the domain. There are corpora like OpenITI available. So in English, we'll have to first start with assembling the corpus and pre-training the language model. So on the image, you can see what type of data we assembled. The corpus is really small. It's only 47 million tokens. So we have to employ some workarounds to pre-train language model. So what do we do? We first of all use we pretend in continued fashion. So we initialize weights from existing checkpoint like bird-based uncase. Thank you. Next, we employ contextualized weight distillation and also two-stage pre-training. I will refer to our paper here to more details, to read more details about contextualized weight distillation and two-stage pre-training. But in short, about contextualized weight distillation, what I can say is that, so we initialize from the existing checkpoint, but at the same time, we introduce also Islamic terms. So what we do, we find these Islamic terms in Islamic corpus that we assembled, we extract sentences, and then we tokenize it using bird-based uncase. So in that case, because Islamic terms absent from the vocabulary of bird-based uncase, they will be broken into subtokens. So what we do, we averaging across the subtokens, and then we aggregate across sentences. So that give us contextualized weight distillation. Curriculum learning is quite simple here. It's just two stages. So at first stage, we mask and predict tokens. Then we increase complexity by masking and predicting whole words, and that helps to introduce the model to more diversified textual input, which is very crucial in case of the small corpus that we use. So here we got a domain-specific model for Islamic domain in English, and for Arabic we use CL-RD. And our next step is we're preparing information retrieval model. So we use Colbert and centered transformers. So in case of centered transformers, what happens is that there is average pooling layer that gets added on top of BERT embeddings. Then we use consigned similarity to retrieve the answer. Colbert model offers more fine-grained interactions. So the consigned similarity is calculated between each query term and the document or verse term. But both models are trained in a similar fashion using MS Marco dataset that's for information retrieval. And here, that's the mind heart negatives. That's the reference that we use for training both models. So here we have, so now we have general domain information retrieval model. Now we want to get to domain-specific information retrieval model. So what we do is data augmentation. So, but for Arabic, there is one more extra step because we actually do not have a general domain data set to prepare information retrieval model. So among other techniques that we experimented with, like knowledge distillation, the most successful was machine translation. So we use machine translated data and prepare, again, general domain model for information retrieval. So now how we move to domain-specific model. To move to domain-specific model, normally data augmentation techniques are round-trip translation, paraphrasing, or we involving denoising autoencoders. So it implies data distortion, which is quite suboptimal in case of religious text, heritage text. So what we propose is technique that is more favorable in case of retrieving from the Holy Quran. So what we do is that we are using the text of Tafsir ibn Kathir, which contains a lot of relations between verses. So we start with pairing. So we extract the relation between verses, but not all the verses will be interpreted as the signal of positive, strong positive correlation. So what we do next is we do filtering. So we use a cross-encoder model that score the pairs and we filter. Then also at the same time, what we do is we sample hard negatives. We sample hard negatives. We sample hard negatives by breaking the corpus of Tafsir ibn Kathir into passages. And we use information retrieval model that was just trained on domain specific, on the general domain, to retrieve these hard mind negatives. And here we combine and continue training on in-domain data. So that's briefly that. Here I would like to show you the results. So you can see that actually the English models, they are systematically outperform Arabic models, which can be explained by the complexity of Arabic language. But at the same time, the Arabic models, they are not far behind. You can see that here, Colbert model is doing especially well for Arabic. Well, we can assume that probably these fine-grained interactions that Colbert model offers can be very advantageous for the language with complex morphology, such as Arabic. So yeah, the Colbert model really doing really well. I will show you the last slide. What I really would like to say here is that we deployed this model. So apart from the evaluations, I really invite you, you go to our website, you test it for yourself. Honestly, I was hoping I can show you the test case, but there's not enough time anyways, right? So please, that's the URL and you can test. I'm good on time, yeah. Yeah, that would be it. Thank you so much.
Thank you. Can you show us the answer?
Yeah, I would like to maybe if I can go to the. I think you just maybe test. No, I need to go to the website, but I think not enough time, guys. I really suggest you just test it for yourself. That don't believe everything I say.
Okay. One question.
Yeah.
Thank you for presentation. Like I have a question regarding the selecting hard negative part. Like
Yeah.
I didn't get it. Is it like contrastive loss, triplet loss? Or...
Yes, it's in favor of contrastive learning. So we use multiple negative ranking laws. So we're using several negatives. Mostly that's in batch negatives. And I call it hard negatives because they are quite similar to the positive, but so there's certain relevancy, but not exactly the answer. So does that clarify? Mm-hmm. That will be, yeah.
Great. So we're on our last marathon talk with Kamyar Zainalapur, presenting Arabic I-Cross. I'm not sure, Arabic Cross, Arabic I-Cross. How do you say it? All right.
Hi everyone, I'm Kamyar. I'm from the University of Siena. So today I'm gonna present a work which we tried to generate crosswords using the LLMs. So yeah. So for the person who are not familiar with the crossword are the linguistic games which from the hint or clue you are trying to get to the sum of answers. Okay, and then also you need to fill the grids, some grids using these finite keywords, which are some intersection between some letters. So the crosswords are beneficial in different aspects. You know, they can improve the vocabulary, word exploring, you know, the lexicon, the refinement of the technical terms, and it can increase the problem solving, critical thinking, and memory, you know, retention. And also it's an enjoyable experience. So in this work, we tried to gather the data, kind of big data set in the clue and answer pairs. And also we try to apply the different approaches using the few shot, zero shot learning, and also the fine tuning. And we tried to find the different ways to verify the acceptable clue and generated acceptable clue answer pairs using the classifiers and also the human supervisions. And also we had an algorithm for generating the schema of the clue answer pairs. So so we tried to gather data sets from the different sources. So got electronic journal and also Al-Jumhuriya journal. So it was one of the biggest problems because these crosswords weren't available in the HTML format. So we needed to try to use the OCR and then human supervision for getting the clue answer pairs. Then we end up with a 57,706 clue answer pairs in the different topics. So the data set is available on the Hugging Face. If you want, you can have access to that. So on the methodology part, you can see we had two different scenarios, path A and path B, which we had two options for generating the clue answer pairs. The first one was generating the clue answer pairs from the given text. So you have the given text and you want to generate a crossword from that. So using that, you can try to put your text inside. Then in the second step, we were trying to extract the keywords from that. And for each keyword, we are trying to generate the clues using that given keywords and the text. And then we needed to validate all of these clue answer pairs if they're good or not. And also the another pass was the pass B, which you don't have the text and you wanted to generate the clue from the given answer. So in this way, in this part, we try to fine tune some LLMs. And so we had some different essential components of the generation, validation, and the puzzle creation. So the pass B, so the first step, we tried to apply the zero and few shot learning approaches. We tried with the different prompts, Arabic and the English prompt. And so we tried to get the clue and get the keywords from the text, and then using that keywords, we try to generate the clues for each keywords. And we tried to validate, so we had a validation steps because not all of the generated clue answer pairs was acceptable. So because some keywords was real long, so we tried to avoid that things. And also we had some inaccurate clues, which the clues are generated from the LLM knowledge, not from the given text. So we needed to wait to filter that things out. Also, we had the hallucination problem, so we tried to filter that thing. So in the filtering, we tried also using the LLMs and also some neural approaches for decreasing this unwanted. Okay, here you can see that. So there are experiments which we try to do in the path A, which is generating the clue answer pairs and crossword from the given text. So as you can see, we tried two different models, GPT-4 and GPT-3.5 Turbo, and in two different prompts. So we try to prompt these models in two different ways, English prompt and the Arabic prompt, in order to see how does these models can affect, to the capability of these models. So yeah, we try to evaluate different parts of the systems, keyword extractor, clue generator, validator, clue validator, and total performance. We try to get 100 Arabic paragraphs from the Wikipedia, and feed it to these different models and with these different prompts. If you check the total performance, we can see that the GPT-4 with the English prompt had the best total performance, equal to the 78% of the generated clues was good, and also GPT 3.5 Turbo was not bad. It was better when we were prompting the GPT 3.5 Turbo in Arabic. So in total performance was equal to the 68.83%. Yeah, here there's an example which how we got from the input paragraph to the clue and answer pairs. Oh, okay. So yeah, first we try to extract the keywords, then generate the keywords for that clue answer pairs, and at the end, we try to filter out unwanted clue answer pairs. So then the next pass was a pass B, which we try to generate the clues from the given keyword. So here we try to fine tune the different models using that data set, which I tried to present you at the first part of the presentation. We try to work with the DaVinci and Curie and also GPT 3.5 Turbo. We try to fine tune these models. And we also try to have some classifiers, build some classifiers in order to find out which clue answer pairs are acceptable and not acceptable. And so we try to fine-tune these language models using the 25,908 unique clue answer pairs. And then after the fine-tuning, we try to generate around 4,000 clues for each fine-tuned model. And then we try to evaluate it from the human supervision. So we saw that using the GPT Turbo, we got the best performance, equal to the 81% of the generated clues were acceptable. And after that we had the DaVinci, with 48.9%, and the Curie, it was a less, 21.35%. So then using that data set, which I explained, that we tried to evaluate around 12,000 clue answer pairs using these different models. So we try to get a subset of the data set in order to 6,000 validated clue answer pairs, and we try to fine-tune the other models in order to classifying the good clue answer pairs from the not clue answer pairs. So we try to fine-tune the DaVinci, Curie, Bobby-Page, Ada, and also the Arabic BERT based. So which we got the best performance using the DaVinci. And here you can see different some examples from the with acceptable clue answer pairs and non-acceptable clue answer pairs from the different clues, and using the human evaluations, we tried to evaluate if they are good or not. So and here is is a full form of the curated puzzle, which I showed you in the previous example. So we try to generate this schema using the generated clue answer pairs. Okay, so here we try to introduce the the data set using of the clue answer pairs in Arabic, and we tried to working with the LLMs for generating the crossword puzzle in different ways from the given keywords and given paragraph. We got around 95% high quality keywords, 94% acceptable and relevant clues, and 89% detections in the validation phase. And we had the algorithm for producing the layouts, the schema of the crosswords, and also some guidelines for the getting the access. So thank you so much for your attention. So, and paper and data are available here.
Thank you.
Unless there's an incredibly burning question, I don't see, we're 9 minutes into, so I'm unlucky for you to be the last talk, but it's really cool. Very nice work. So we have a break until 10:30. For all the 9 people presenting in the next session, please make sure Bashar here, volunteer, help get him what he needs. Also, you can talk to Karim Darwish, who will be the session chair. If you introduce yourself to him. Thank you very much, everybody. Hey, I need my coffee. It's 11 o'clock. You come back. Thank you very much.
Hi. So I think I got your slides.
Okay, good. So do we see the slides on the screen? Or not?
I think it should be able to. I think it should be able to.
Like maybe duplicated.
It's not a PDF. It's a PDF or a PowerPoint. PDF is hard. It's not like it's a here. Like you cannot duplicate the things.
So can I send you
the PowerPoint?
No, I don't have Google Slides.
So you can download as PowerPoint. Google Slides.
Would it maybe damage the format? I can try it.
If it's Google Slide, I can share it from the drive. Google Slide should be fine.
Also, I'll send you on the same URL now. On
yes. Can I sign up for this? Seriously. Hi, how are you? I think I got your slides. The Muhammad presentation.
I just want to know how it works. So we're just given slides with this. It's no clicker. There's no.
There's a clicker if you want.
Okay.
Depending on how fancy you want to be. Look like this.
I just don't want technical issues.
Yeah, don't worry. Not like it's not gonna be hard. I think I will use this just to basically.
Okay.
This is easy.
All right.
Yeah.
Sure. Thank you.
So hi. Are you good? Do you have a okay, one second. Which one is better?
Send you both the PPT. I'm not sure if your formatting went okay. Hmm? Yeah. Okay. Do that one. Oh.
Oh, sorry.
Oh. Hello.
نعم معنا presentation تقطيعية بعديها شيء على الإيميل أكيد الأدرس أكتب لك الأدرس can you double check All is good? Okay, perfect.
It will be that duplicated.
I think so. Let me double check. Yep. That's fine.
Mm-hmm. Yeah. Perfect.
Good?
Yeah.
Awesome.
Excellent.
Awesome. Thank you. All is good. الحمد لله. أمورك تمام؟ هلا إذا في واحد باوربوينت يكون amazing صراحة. باوربوينت أسهل يعني. نعم. اوكي هو اول واحد طيب اوكي قلت لك لا احنا 9 دقايق معناها يبقى عندك لا خلاص اوكي 9 دقايق معناها طيب انت جاهز على اول سكند.
I hope everybody started getting seated so we can start the next session. And we're going to go through a marathon of papers. So in 90 minutes, we should be covering 9 papers, which means each presenter will get about 8 hours to present. I guess coffee didn't work. So it's 8 minutes worth of presentation and 2 minutes worth of questions. And our first presentation is by Sakhr Khraif and is going to be about evaluating ChatGPT for sentiment analysis. So, and the clock starts now.
Okay, you can. Assalamu alaikum. Good morning, everyone. This is Sakhr Khraif, and we'll be talking about evaluating ChatGPT and BARD AI for Arabic sentiment analysis. This work was done during last summer by my colleagues at KAXT and summer interns from Imam University and Qasim University. So we evaluated 3 large language models, GPT 3.5, GPT-4, and BARD AI, or BALM-2, for Arabic sentiment analysis on the Saudi dialect. We used the SDTC corpus, or the Saudi dialect Twitter corpus for this task. As a baseline, we fully fine-tune BERT-based models on the SDTC, and we evaluated the LLMs both for text generation and sentiment analysis. This is the distribution of classes in the dataset. We have 3 classes, neutral, positive, and negative. Obviously, from Twitter, mostly it's negative, 61%. We have 2,690 tweets. This dataset was published in 2018. We split the data into 75% for training, 25% for testing. We always evaluate in the test set. For training, we use it to fine-tune the BERT-based models, and we use 90 tweets from the train set as development set for the prompt engineering, 30 for each class. Okay, so we conducted 4 experiments. In the first set, sentiment analysis. First one was a baseline, BERT-based models. And the second one, we tasked ChatGPT and BARD AI to classify text into 3 classes, neutral, positive, and negative. And the second set, we evaluate the generated tweets from these models. Experiment 3 is manual evaluation. Experiment 4 is automatic evaluation. Okay, so we tried different BERT-based models. Best one was our BERT base trained on Twitter data. We haven't tried, there are other models like Camel BERT Mix. We didn't try it. Maybe it will be better than the dialect one, but this is just baseline. We got 79 for F1 score. And for classification using the LLMs, we tried with different number of shots. we define shot here to be a triplet of tweets: negative, positive, and neutral. I know it's not the standard way, but sometimes when we ask the model to generate sentiment in positive, for example, and ask it to generate for neutral or negative, it fails to do so. So we tried different number of K0, 1, 3, 5, tried different prompts, both in Arabic and English, and we selected the best prompt that achieves the highest accuracy in the dev set. Also, sometimes models refuse to answer when we give them negative tweets. So we assume if it refuses, it's negative. Okay. So here are the results. Best model was GPT-4 with F1 score 77, close to the best BERT-based model. And the worst one was BARD AI. Okay, for the second set of experiments, generating tweets, we tasked BARD AI and ChatGPT to generate tweets. And first thing was to evaluate the prompts on small scale, whether the tweets are natural, you expect them to be on Twitter. Also, we want tweets to be in Saudi dialect. And finally, we don't want to have very short tweets because sometimes models tend to generate very, very small tweets, like 2 words. Then, after selecting the best prompt, we generate N tweets similar to the training set. And after that, we manually evaluated the generated tweets and automatically. So for manual evaluation, we selected 150 tweets, 50 from each class, and asked annotators 3 questions. First one, making sense. Is the generated tweet correct and understandable? Second question was appropriateness for Twitter. Do you expect this to be in Twitter? Because sometimes it generates something, but okay, it makes sense, but doesn't. It's not likely to be on Twitter. Then matching label. Does the text match the label? Because sometimes you ask it to generate a neutral tweet, but it's negative or positive. Then I hope you can see the numbers here. So here we are showing the how many times an annotator agreed with or answered yes or no for each question. And for the last one is agreement between annotator and the instructed tweet. You can see that the neutral is the hardest, even for GPT 3.5 or GPT-4. And this is also the same with BERT. Neutral is the hardest case to distinguish. Okay, and then we use the generated tweets as a training set for BERT-based models. First line here is the authentic data set, and here each line corresponds to the corresponding model. And then here we mix the generated tweets with the authentic tweets. Actually, we didn't gain anything by combining the generated tweets with the authentic ones. For some cases, like in GPT 3.5, we got very low results when we train on the generated tweets and test on the authentic ones. Okay, here are some interesting findings. BARD tends to be less reliable than ChatGPT. Here we asked it the same question twice. First time was negative, second time was neutral. This is an interesting thing. We asked it to regenerate text in the Saudi dialect, and then said, why don't you write the tweet yourself? Okay. Very human thing, huh? And besides that, we found that fully fine-tuned models still better than the LLMs for this task. And GPT-4 outperforms both 3.5 and BARD AI in sentiment analysis for the Saudi dialect. And we found that LLMs still cannot generate good tweets for this task. Finally, neural tweets are the hardest to classify and generate. Okay.
Thank you so much. So we have time for one question.
I can't breathe now.
Yes.
I was just wondering, I have been totally unable to get at least GPT 3.5 to produce any Arabic dialects, just modern standard Arabic. I don't know if you encountered the same difficulty. I mean, it looks like maybe Bard was having trouble too.
We try on different prompts for 11 prompts, both in Arabic and English. Yeah, sometimes, I mean, depends on what kind of text you want to generate. Like Twitter, maybe it's easier to have than other genre.
Okay, let's, I'm sorry, thank the speaker one more time. Next presenter. 8 minutes, and then 2 minutes for questions. I'll give you a warning before your time is up by 2 minutes.
He will run it from. Hello, everyone. My name is Magdy. I'm a postdoctoral research fellow at Mohammed-Bassam University of Artificial Intelligence. Karima Kadoui and I will be presenting our paper, Tarjamat, Evaluation of BARD and ChatGPT on machine translation of 10 Arabic varieties. This work is a collaboration between Mohammed-Bassam University of Artificial Intelligence and the University of British Columbia. Thank you. The rest of the co-authors are listed here, as you can see on the screen. So I'd like to start first with our motivation. As you know, that large language models are getting increasingly popular with powerful capabilities on a wide range of tasks. For example, OpenAI's ChatGPT shows great performance on many language tasks. However, it is not clear how it would be fair on Arabic, and specifically on Arabic machine translation. So our goal here is to evaluate ChatGPT 3.5 for and BARD on machine translation of 10 Arabic varieties, including Classical Arabic, MSA, and several dialects, which are represented here by their flags on the figure, against commercial systems, Google, Microsoft, Amazon, and Meta. We evaluate these varieties under 0-shot and 5-shot settings. So let's move on to the data sets. Our evaluation involves newly prepared test set that never exposed to any large language models. These data sets include Classical Arabic. We manually collected 200 sentences from Open Islamic Text Initiative, OpenITI datasets. For the MSA, we collected 200 sentences from current event news, namely from Al Jazeera and BBC Arabic online news websites. For the rest of the Arabic dialects, we collected 200 sentences across 8 dialects, a total of 1,600 sentences, which represent different countries from the Arab world. For example, we have dialects from North African countries, Gulf area, Taizi, Levantine, and finally Egyptian Arabic. For the methodology, we started with the prompt design. We conducted a pilot experiment to decide on the prompt to identify the most effective prompt for Arabic to English translation tasks. We did this only with ChatGPT 3.5. As you can see that we have 3 prompt candidates, English, Arabic, and an elaborate English prompt. We tested the prompts on 100 MSA sentence to English translation samples. In terms of blue score, the evaluation showed that the concise English prompt outperformed the Arabic and English ones. For the evaluation matrix and baselines, as you can see that we employed 5 different automatic matrix. For example, Blue, Comet, CHR, and the rest. For the baseline, we compared ChatGPT 3.5, 4, and BARD against 3 commercial systems, Google, Microsoft, Amazon, and 1 supervised no language left behind, Meta.
We conduct our studies on different L-shot settings, namely 0, 1, 3, and 5 shot. We try to keep it consistent between the 3 systems with 0 and 5 shot, but unfortunately, due to the fact that BARD API didn't have BARD didn't have an API at the time that we conducted this experiment, it was not feasible to do the 5 shot for BARD. For the results, in the big picture, we noticed that there's a pattern with the GPT-4 5 shot having most of the best results. We also noticed some points attributed to GPT 3.5 on 5 shot for some varieties, and we noticed that Google Translate is the best commercial system. Now, looking at the specifics, is GPT-4 better than GPT 3.5? The answer is in most cases yes. On the 0 shot setting, we noticed that GPT-4 outperforms 3.5 by 1 to 3 points, blue points on all metrics on average. We also noticed that GPT-4 with 0 shot is on par with 3.5 on 5 shot. We noticed on the 5 shot setting that GPT 3.5 ends up closing the gap with GPT-4 and even outperforms it on 6 varieties, but only on blue. Now, are GPT 3.5 and 4 better than BARD? Again, in most cases, yes. BARD is only better in classical Arabic, Egyptian, and Jordanian. And in the overall scores, we noticed that GPT-4 comes first, followed by 3.5, then BARD. Are GPT 3.5 and 4 better than commercial systems? Yes, but only on dialects. Google Translate shows the highest performance on classical Arabic and MSA, and even Jordanian. Across all varieties, we noticed that GPT-4 comes again first, followed by 3.5, Google Translate, Microsoft Translation, and finally, Amazon Translator. Are GPT 3.5 and 4 better than the supervised baseline NLLB? Yes, they are. NLLB is on par with GPT 3.5 and 4 on MSA, but it falls significantly behind when we add the dialects, and we notice that we go from an average of 23 blue points all the way down to 12. Are instruction following models better at dialect translation? In most cases, yes. The gap between the best instruction tuned model, which is GPT-4 5 shot, and the best commercial system, Google Translate, across all varieties is 1 3.5 blue score, but then it goes all the way to 4 when we exclude classical Arabic and MSA, giving us the idea that in most cases, the only advantage that Google Translate takes comes from the MSA and CA. We also noticed that Google Bard does not always follow human instructions, and we saw it in the previous presentation. We just evaluated in terms of helpfulness independently. We noticed 4 types of errors, namely wrong target language, and it's when Bard translates to a different language than English. No translation, when it simply says that it can translate or that it doesn't speak Arabic, and it says that in Arabic. Content filtering, when it claims that the sentence given is toxic or violates the community guidelines, but we have curated the sentences ourselves, and GPTs didn't have a problem with this, so Bard is really just being dramatic. And degeneration, when Bard gets stuck on a specific word and keeps generating it repeatedly. The most frequent issue that we notice is the wrong language, where Bard translates into MSA instead of English, and it most comes up when translating from dialects. When we notice that it does the wrong language from MSA and CA, it stems from mistaking the translation for a text completion task rather than translation. We also report some metrics and some analysis on the different draft on Bard, and you can check that on our paper. Overall, we theorized the error rate may be proportional to the resource availability for a given variety, given that the Mauritanian and Yemeni dialects were the most problematic. Finally, we noticed some other behavior like citing sources that are not relevant to the response, answering the input sentence instead of translating it, giving its opinion, or adding details that are not included in the input sentence. In conclusion, we have evaluated Google Bard GPT 3.5 and 4 on 10 different Arabic varieties against commercial systems and a supervised model. We have also created a multi-dialectal Arabic data set to ensure that we're evaluating on completely unseen data. LLMs can do well on some varieties, but not so much on those with scarce public data. And finally, BARD falls significantly behind when it comes to adhering to instructions.
Thank you for the presentation. We have one question, Jack.
I know there's no time, I'll be quick. I'm studying Palestinian Arabic very passionately, and I use GPT-4 to translate, and the results are very poor. It gets the verb conjugations completely wrong often, or it mixes in MSA. It's practically unusable according to my experience.
So from my understanding, you're doing English to Palestinian.
Yeah, but both ways.
Okay. We have not tried the other way around, but we have noticed that on average, when translating from dialects to English, it seems to perform better than the other way around.
Quick question. How did you confirm that those samples are not in any of the previous data, particularly the classical Arabic from ITI? I mean, presumably they existed for a long time. How do you know they are not in any of the large language models?
For MSA and the rest of the dialects, we ensured it because the data that we have curated, well, for MSA from news websites that were recent, and for the dialects, we manually collected it from shows.
So let's thank the speakers again. Can we thank the speakers again? Our next speaker is Sabri from QCRI, and he's going to be talking about evaluating LLMs for multi-turn instructions. I will give you about 2 minutes before your time is up.
Thank you, Karim. So we are interested in benchmarking LLMs in a different setup than the usual one, where we want to look at the evaluation in cases of open-ended scenarios. And the status of LLMs benchmarking currently cover mostly core knowledge benchmarks like with MMLU and other data sets, as well as instruction following and conversational benchmarks. But however, all these benchmarks, they're mostly kind of supervised setup where we have multi-choice questions, or we have kind of golden standard response. So it's kind of a supervised setup. But we want to go beyond that, where the answer can be formulated in a much different ways, but still can be considered as a correct answer. And most of these benchmarking have been focusing mostly on English language. So one way to solve this challenge is to evaluate based on humans. So humans would look at the assistant response and then give a scoring. But such setup is time consuming. You need to get a lot of evaluation to get statistically significant numbers, as well as you need to recruit the right skills to be able to judge areas such as reasoning or math. So that's not really a promising direction. One way to solve these challenges with human evaluation is to consider an LLM as a judge approach. And this has been recently introduced with the empty bench dataset, where GPT-4 or GPT-3 or other LLMs can be considered as a judge to evaluate other LLMs. So this is done through in-context learning. So we prompt the LLM judge with a judgment prompt, as well as the response from the assistant, and ask the LLM judge to give an explanation of his judgment. And we have a list of criteria for judgment. And in our case, we took exactly the same English LLM LLM judge prompt, just to be able to have a kind of one-to-one mapping of the question and answer. And in terms of criteria, we focused on helpfulness, relevance of the answer, accuracy, depth, as well as creativity. And we asked also for an explanation. And the scoring is a numeric scoring from 1 to 10. Also, since each question has one second follow-up question. We gave the first answer as a context, and the second prompt focus only on the second answer of the assistant. So the empty bench study has shown agreement between the LLM judge and the human evaluation, so up to 85% agreement. And also a survey of the human evaluator have accepted the LLM judge response up to 75%. For the Arabic study, we looked at the explanations given by the LLM judge, and we tried to cluster them across scores and see if they're consistent across assistant. And we found that it's quite the evaluation is quite consistent across all the assistants we've looked at. So the ArabicNLP bench we are proposing is really like parallel of the English one. It has 8 categories. It covers literacy, reasoning, math, and for each category we have 10 questions, and each question has a follow-up question. So in total we have 80 questions with 2 terms. And this is an example of in role play category where we have the T1 is the first question and the follow-up one. And in terms of curation, we did automated translation, but we curated carefully each and every questions, and we gave social and cultural context during the curations, as well as the language context. For instance, if you translate the name of a person, then we give an Arabic name for it, as well as the examples are, culturally carefully translated. So in the selection of the LLMs to be included in the benchmark, we considered the GPT models as a baseline, and many models, open LLM models that are below 30 billion, around 30 billion parameters. And so we have on the left, we have the first column shows the turn 1 score, empty scores in Arabic, and the turn 2 scores is the follow-up question scores, as well as the average. On the right-hand side, we have on the x-axis the same scores in the table, but we added also the English scores. So each point give us an indication of the performance on both languages, as well as the changes across the terms. So if the models are above the diagonal, it means they have more English skills versus Arabic and so on. And if the turn 1 and turn 2, we have a degradation in performance in terms of the conversational skills, then we'll see that the points will move downward. We also looked at the performance per category, and we could see that in terms of writing literacy, the Arabic models are reasonably scoring well, but they lack mostly in reasoning, math, those categories that have the least performing among most of the top models. And the right plot shows the top 3 models, which are GPT-3, JACE, and Phoenix. We excluded GPT-4 because of the bias of judgment, because we are using GPT-4 as a LLM judge. Since our data set is a parallel to English, we were able to look question by question at the difference of scores. So this heat map shows on the x-axis the models, and on the y-axis on the models, and the x-axis the category, and the difference between the scores English versus Arabic. So if we have warmer cells, means that the English is superior in that model, versus the cooler one shows that Arabic is superior. And we ranked the rows in terms of performance. So the top ones are mostly English superior, versus the lower one are either balanced or Arabic superior. And we could see that mostly Llama-based fine-tuned models are scoring high, versus the pre-trained model in Arabic like JACE and GPT that are scoring bottom, which have equal skills in both languages. In conclusion, we think that the ArabicNLP mesh we are proposing is a step forward in evaluating LLMs in Arabic setup in open-ended scenarios. And we could see some limitations of the models in terms of reasoning, math. This is a known problem for LLMs, but it's also prominent in the Arabic setup. currently there is still a gap between GPT models and the other OpenLLM. I think there is still work to be done in that direction. And we've seen a lot of attempts to fine-tune Llama. Llama is not known to have Arabic skills, but still has some base actually capabilities, and fine-tuning them, Llama models actually really boosted the performance of those models.
Thank the speaker. Can I get, we have about a minute for questions. And if the next speaker can come and set up while the questions are being answered. Questions?
Hi there, great work. I'm curious about the efforts that you've spent in validating using GPT-4 as a judge in comparison to using human judges.
So in this study, we did not do human evaluation for the Arabic case, but for the English case, the LEMSIS project, well-known project, having, the Kona and other projects. So to actually have a paper in Europe, and they did an extensive evaluation, which I think it took months of study. And what they did basically, they put fast chat for the wild, and people start using it, and they were able to collect a lot of responses from humans. So I think without such a wide effort, it's very difficult to do human assessment. And for us, it was really like a low-hanging fruit to bring such a broad evaluation to the Arabic space. So for the GPT-4 is really straightforward. Everything is automated. Of course, we need to spend a lot of time on curating the set of questions, which is still manageable. Like 80 questions are still plausible to be done within a short window. But since the agreement between human and GPT or LLM judge is high, we could rely on that correlation. But probably there's a need to redo it in other languages, I guess.
Thank you so much. Let's thank the speaker again. And next speaker is saying Yun from is talking about grammatical correction for Arabic using LLMs.
Hello, everyone. My name is Sang-Yun Kwan, and I'm a master's student from the University of British Columbia. And today I'm here to present our team's work called Beyond English, Evaluating Large Language Models for Arabic Grammatical Error Correction, where I collaborated with Gagan, Muatez, and Dr. Mohamad. So grammatical error correction is a natural language generation task of correcting different kinds of errors such as spelling, punctuation, grammatical, and word choice errors. So an intelligent GC system would receive text containing mistakes and produce its corrected version. And here's an example of a capable Arabic GC system correcting different types of translation task. Translating an erroneous sentence into a correct sentence. However, one downfall to this approach is that it requires a lot of data for optimal performance. So instead of translating this English sentence to an Arabic sentence, we would translate an error sentence to a corrected one. So there has been tremendous development in GC in English and in other languages that are rich in resources. But GC in Arabic poses several problems. First, Arabic consists of complex grammar and is rich in morphology. Also, there are only 3 benchmark data sets making it low in resources. Recent literature has shown the potential of large language models in GC in English. So in this work, we wanted to explore the capabilities of large language models and see if they can help overcome the inherent limitation of Arabic GC. So here are the 2 benchmark data sets we use. We use the CALP 2014 and 2015 data set. So for our first experiment using large language models, we first prompt ChatGPT 3.5 and GPT-4 using the official API. We use 2 different sets of prompts. We use the chain of thought prompt and expert prompting. So these prompts are implemented in a 2-stage format, reasoning extraction and answer extraction. So during the reasoning extraction phase, we engage the model to formulate an elaborative reasoning pathway. And during the answer extraction phase, we guide the model to produce its output in a particular format. And for a few shot also for the few shot learning settings, we provide the in-context examples in this phase. For expert prompting, we provide a more specific prompt to give the model an expert identity for GC during the reasoning extraction phase. The part highlighted in different colors on the figure for expert prompting are the additional information we provide. For a second experiment using large language models, we instruct fine-tune different LLMs such as Llama, Alpaca, and Vicuna using an instruction fine-tune data set we created. And here's an example of the format. These are the results on our experiments using LLMs, and it shows that ChatGPT 3.5 and GPT-4 are superior than fully instruction fine-tuned model, even with just few shot learning. In this work, we also wanted to investigate different approaches to GC, such as the sequence-to-sequence approach and the sequence-to-edit approach. And these are the models we train for each setting. And so for sequence-to-sequence model, we train RBART, RT5, and RT5 version 2. And for sequence-to-edit models, we train RBART version 2 and MART version 2. Here are the results comparing LLMs to sequence models. The main takeaway here is that GPT-4 is able to get competitive results, even outperforming fully fine-tuned models, but still falls behind the best performing model, which is the RT5 version 2. And here are some results comparing sequence models to sequence edit models. The main takeaway here is that sequence generally perform much better. However, it is good to know that sequence model display a high score in the precision metric. So previous literature has shown the efficacy of synthetic data in English as well as in Arabic. So in our work, we distill knowledge from ChatGPT by first generating 10,000 parallel examples, then training a reverse model using RT5v2 and generate 5 million and 10 million parallel datasets. When we prompt ChatGPT, we adhere to the Arabic learner corpus error-type taxonomy to ensure generating diverse types of errors. And here's an example of how we prompted ChatGPT. And here are the results after training RT5 version 2 using the generated synthetic datasets. In here, we can see a consistent improvement as the size of training examples increases. And also, we also do a fine-grained analysis on error type performance and under different normalization methods. Here are the results of the top performing models from each approaches under different error type categories. And here are the different error type categories. And also, we do the same for normalization methods, providing results under 3 different normalization. So lastly, in this work, rather than achieving state-of-the-art, we wanted to investigate different methods in doing GC. However, we have continued to work on this task, and we have currently achieved the state-of-the-art performance, including to the recent paper that has been accepted to EMNLP 2023. In here are results in comparison to this work. This was not of our paper, as we are only able to evaluate against the work after the submission deadline. And as for limitations for this work is that it primarily focused on MSA, and there's no coverage in dialectical Arabic or classical Arabic. And this only covers sentence level GC, as there was a maximum token limitation during when we were working on this work. And lastly, the uncertainty around the extent of Arabic data on which ChatGPT has been trained on poses challenges for direct comparisons with other pre-trained models. Thank you.
So we have questions for probably 2. Yes, can get status.
Hey, good work. So for the seek-to-edits model, when you use RBART and MARBART, are they based on Gector or some other?
Yes, we use the Gector model.
And what was your vocabulary size?
I can't remember it for now.
Okay.
I can check on it.
The other question, when you report results compared to our papers, the M3 and the Model 1, Model 2, are they trained on synthetic data?
Where this work is actually in progress, so I can talk about.
So you cannot share. Okay,
yeah, sorry.
Sounds good.
Okay, next question. And the next speaker, can you kindly come and set up?
Thank you for your presentation. I have just one question regarding the decoding step. And as you said, there is a encoding and decoding part, right? So in the decoding step, in the decoder, did you use greedy decoding or just used beam search?
We use beam search.
Is there any specifics in the beam search that you have done, or just a normal
just normal beam search?
Okay, thank you.
So we have time for one more question, if need be. If not, let's thank the speaker. And our next presentation is going to be by Mohamad Abdul-Mageed. And he's going to tell us about octopus. I personally like octopus. And squid.
Like, yeah, obviously.
And
Okay, assalamu alaikum wa rahmatullahi wa barakatuh. Hello, everybody. My name is Mohamad Abdul-Mageed, and I'm going to present this work from my group. This work is in collaboration with two of my postdocs, Abdul-Rahim al-Madani and Mu'taz Billah al-Judi. Yeah, so this is the title of the paper, Octopus, a multitask model and toolkit for Arabic natural language generation. So this is the outline of the talk. So I'll tell you a little bit about Octopus, what it is, the tasks it covers, how we train the model, then the evaluation, and then I'll show you some examples, and then I'll talk about the toolkit itself. So what is Octopus? Well, it's a model. It's a new text-to-text transformer model. It's our second version of ART5. I think some of the colleagues here, including Sakhr sitting there, was asking me a few months ago, are you gonna release a pre-trained model that also kind of like fine-tuned on some of the downstream tasks? And I said, yes, we're working on something and we'll release it. So that's it. That's basically Octopus. But basically we kind of like, rehabilitated the first version of ART5 a little bit, and I'll tell you how we did that. And then we have 8 generation tasks in Octopus. It's a multitask model, and I'll talk about this. It's also a toolkit. So it's a Python-based and command line toolkit. So what are the tasks involved in Octopus? Well, we have a bunch of these. So Octopus can do title generation. It can do question generation, summarization, paraphrase, diacritization, grammatical error correction, question answering, and transliteration, all in a single model. So what is ART5 version 2? Well, as I said, it's a text-to-text transformer model. We have used more training data, more pre-training data, so up to 250 gigabytes of data. It's also a diverse set of data. So it involves classical Arabic, modern standard Arabic, and dialectal Arabic. And we also trained it to be longer sequence. It can encode and decode longer sequences up to 2048 tokens. So a bunch of improvements across the board. So how does it compare to the first version? As you can see here, so data comparison. So ART5 had actually 3 versions. We had 3 models. ART5 version 2, it's only a single one, but it has like different data sets together. It's more diverse because we involve with classical Arabic data. I saw some works here also that focus on classical Arabic. So I'd invite them to try ART5 because it does have classical Arabic in it. And as you can see, it's longer sequence. So let's talk about Octopus itself, which exploits ART5 version 2. We had 3 types of settings. First, we just do unsupervised pre-training, which is ART5 itself, the second version, with unlabeled data. But then we take that model and then we supervise fine-tune it, right? So we just, take each of these downstream tasks that are labeled, and we just like fine-tune that model. All of this as a second stage. So pre-training, then fine-tuning. And then we report on these models, how do they fare. But also another setting that we have is that we just like mixes a pre-training data, the unlabeled pre-training data, which does like this denoising objective in these models, with downstream labeled the data sets, and we do both together. So that's like joint pre-training and fine-tune. So 3 different versions, as you can see here. Lots of results. I don't have time to talk about them, but we show different, settings and like how the different models fare and so on. I would just say that we report single task models, like single task, like on each downstream task, we have just a fine-tuned version of RT5 version 2. And this is like the first column that's highlighted in red here. It doesn't do as well as when we do everything together, which is in the last column, when we have tasks where higher score is better, like text classification, sentiment analysis, for example. But where lower score is better, actually single task models do well, as you can see, like this number here. This is like a diachromatization, character level diachromatization task, so they do better. Anyways, so these are some examples of things that the model can do. So if I give it a news article, I can actually generate titles of this news article. And this is very recent piece of text that the model hasn't seen. It can also kind of answer questions, متى تقام مباراة بوليفيا والبرازيل, then it will say SAPTA, and that's based on the text. It can do other types of things, question generation. It can actually generate a question to an answer that you give as well. So this can actually be used to generate data that, people can do different things with it and so on. Some issues with open-ended, open domain question answering. So like the data sets we use to fine-tune and so on are not open domain question answering data sets. There's a little bit of that. But anyways, the model struggles with this. But it actually can handle lengthy sentences very well, as I said, because it's longer sequence. And there's a little bit of negative task interference here when we put all the tasks together and try to fine tune. And I'll show you an example of this. For example, for the diachromatization task, if I take a line of poetry, this is Al-Mutanabbi, the multitask model is actually not as good as the single task model, as I said before. There are some examples here. I don't have a lot of time to talk about them, but I'm just going to say that the diachromatization component of Octopus is not very strong, although we actually have single task models that do diachromatization very well. So this is the toolkit, a bunch of options and so on. So we released this, so you can download it as a Python library. We also have a demo that I will show you, but these are different ways to work with this Python package. This is the online demo. You can scan this and you can try the demo if you wanted to. And you specify the task, and there are some different options there that you can explore. With that said, there are a couple examples. The first is about question answering. Both of them are about question answering, I think. And this is like the model actually working and doing its thing. That's all.
Thank you. We have time for probably 2 or 3 questions. Yes.
So if I'm not getting any questions from Sakhr, then I assume you were happy.
Yeah. Hi, Mohammed.
Yeah.
My question is related to performance on the GPUs versus CPUs versus to run this toolkit.
Right.
Is anything you did to improve, or just you put the model and you tell us just take, right? I mean, there are some pipeline frameworks maybe that are useful.
Right. Yeah, it's not a very large model, so you can run it in Google Colab. You can run it on a personal computer as well. It does need GPUs though, so that's a problem I cannot solve. But it's not a very large model anyway. Yeah, and actually, you saw from some of the previous papers we presented, so Sang, for example, you saw that actually this version 2 of RT5 does very well on a lot of tasks. It does better than GPT-4 on many of these tasks, as you saw in the previous presentations.
I have actually a question.
Yes,
So,
please.
I mean, you're working, it's ARA T5, so obviously it's going to be in Arabic. And I was looking at multilingual T5, and tokenization has problems and so
Right.
forth. So how easy or difficult it is to actually generalize this to many languages to work at the same time, as opposed to just working on Arabic? Because there are many people, people who have applications that are not just monolingual, but multilingual.
Right. I mean, there's a lot of work, as you probably know, on generalizing these models. I mean, there is some work on extending vocabulary of an already existing model. So people have, and I'm happy to talk about this offline. So that's one way. You increase the parameters of the model a little bit, but how do you actually extend the vocabulary, like to cover things that were not during pre-training? One approach is just to average over characters that existed in the original vocabulary, if they did exist. If they didn't, so for example, some, if you take Llama 2, it has like Arabic characters, like, you can actually average, and there's some work that does this. They average the weights of these characters to form bigger units, which are the words, and then they kind of further pre-train. There are other approaches I can imagine. But yeah, I mean, it continues to be a problem. And here's a very quick plug in. We just put a paper on arXiv called Fumbling in Babel. We try to do language identification of GPT-4, and we try to see which languages it actually covers. And we find that it doesn't cover beyond 100 languages of the world. And we do this on 600 plus languages. Thank you.
Thank you. Let's thank the speaker again. And our next, okay, so our next speaker is Hamza. He's going to be about Al-Ghafa evaluation benchmark for Arabic large language models.
Yes. Hello, everyone. I am here to speak about the Al-Ghafa evaluation benchmark, mainly for Arabic large language models, LLMs. Okay. So in behalf of my team, I am here, Hamza Al-Abedli, speaking about the Al-Ghafa benchmark for large language models. So what motivates us about this one is because we don't have good large language models in Arabic. So we have a lack also in the benchmark, especially for Arabic. So this is one of the main reasons we are releasing Al-Ghafa. So mainly Al-Ghafa is a multiple choice zero shot and multiple shot benchmarking for questions and also we introduce our own models that we trained just to evaluate Al-Ghafa on, and we also compared with different Arabic large language models. So basically, we collect our data mainly in two sources. One of the sources is web sources, and the other one is the web, like in the internet available data sets in the internet. So as you know, because when you collect the data from the internet, so usually Common Crawl or OpenAI or another from the web sources, the data is not very clean. So we run 5 stages of cleaning the data. So mainly the basic filters, where we remove the short sentences, we remove the HTMLs things, and we extract the text from this data set, from this data. And for the stage 2, we run the deduplication using min hash for each individual data sets. And then we run the stage 3 a global min hash that across all the data sets to remove all the duplication data sets. In stage 4, we do exact substring deduplication, and then further steps, so we do the final quality, for Arabic basically, and that's we kept only 14% of our all the data, but at least we have like better quality data that comes from the internet. So here is like the splits of our data sets. We can see that most of the data come from the web data, from Common Crawl, Arabic Web 16, and our handmade crawl dataset, which give us an additional 8 billion tokens that we can use, and our high quality source we can use. It's very small compared to the web data, which forms about 5% of our data. And for the model architecture, we followed the GPT architecture. We just made small modifications like the multi-query attention, parallel attention, and the rotary embedding that after investigation, we see that could be fit the best for the Arabic. And here is a small table that illustrates the different architecture between the previous models. And so the evaluation and results, we evaluate in 3 things, actually 4. One is the throughputs, and the second thing is in our benchmark, Al-Ghafa benchmark. So it's a multiple choice data set, collection of data sets, basically. So it is 11 data sets that some of them are already checked by human that from our company TII. So the one with the stars that actually has been checked and annotated by some of the employees, that's Arabic native speakers. And we also evaluate in generative tasks. That's 4 data sets we can see here. Also, in terms of performance, we evaluate in some of the different models, and recently JS 13b, which was released like the last month before we launched this paper. So basically, as you can see the results, which was actually a good model that has been released. However, just a small notice that JS 13b has been trained in 32 floating points. So, but in our model, we trained only in 16. We have a competitive result, but when you see this throughputs, we can see an improvement like for almost 2.5 in speed when we go for batch size of 32, which is a huge speed comparison. That's maybe so that our model that is very good on, which is and also we compared. We also evaluate in some of the generative tasks, like basically question answering, and lastly, we also developed the toxicity and bias analysis. So basically, in the toxicity, actually we have very rare models that are evaluating the toxicity and bias, and their evaluation benchmark. So in this, we have a qualitative and quantitative results. Basically, in the quantitative result, we use binary classification. So we generate some of the outputs and see that if it is toxic or non-toxic. And for the qualitative, we generate one answer. And here's a small result. Finally, and conclusion, we releasing our benchmark, mainly the 11 data sets that's checked and by human, and we will keep adding data sets, of course, and maintain this. And our goal is also to reduce the toxicity in the Arabic LLMs, basically, and we will try to have the best models that mainly serve the Arabic community in the future. And thank you.
Thank you so much. Yes, first question.
Thank you. I have a question about 2 questions about evaluation. First, I think many of the data sets you evaluate on are machine translated. Is that right?
Yes, this is actually most of them are machine translated as well.
Right.
This is why some of them are already checked by human and has been corrected by human, actually, like the one.
Okay.
KSAA-RD open book and.
Right. I think it's a terrible practice when people evaluate on machine translated data. It's good that you actually correct this, but I have seen this elsewhere. The other question is, about the range of tasks you evaluate on. So this recent ACL, we have a benchmark ORCA that is composed of 60 plus data sets for Arabic natural language understanding. It's publicly available. And another thing, in this conference, we have another paper, Dolphin, which does the same thing for Arabic natural language generation, 40 different data sets. So I invite you to look at these two.
Sure.
Yeah, okay, great, thanks.
Thank you.
Octopus, dolphin, and orca. I know where you're heading. So we have a question actually from Zoom. And if the next speaker, Asif, can you set up, please?
Wait, 1 second, I just have a...
Not the final checkpoint, but I can't hear you.
Can we take the Zoom question first and then they'll get it with you?
The Zoom question is, what are the quality filters you have used in data processing?
And the data, we didn't have the filters during the data collection, but after the data collection, we have the filters that we shown here. Basically, this is answer the question. Yeah.
So my question is like, why do you train bigger models for 4 epoch? And the next question is, do you evaluate these intermediate checkpoints as well, or like for final?
Of course, we evaluate some of the checkpoints, but not all of them. But we took the last one, which was almost the best, checkpoint that we have. And why we evaluate in 4 checkpoints? Because we don't have enough data in Arabic. So after we filter, as we said, we have only 14%. So the more epochs we do, like to have better data distribution among the model.
Thank you so much. So we'll move on to the next speaker. We have Asif from KAUST, and he's going to talk to us about Gary. I'm curious what Gary is.
Hi, Assalamu alaikum. So my name is Mohamad-Bassam. So a little change in context apart from LLMs. So so Gary is just like graph attention. The key idea is that we try to control the relative isomorphism of embedding learns for different languages. So far, so you can just think that this is for bilingual induction, although we can use these tools and techniques for all those embedding models, also for the LLMs, but tools and techniques need to be developed for that. So these results are basically just for the very basic, like Word2X kind of things. So what existing models used to do was they just try to do or learn some linear or nonlinear mappings into a shared space. But the core limitation is that they are somehow based on under the assumptions that the underlying spaces for the monolingual embeddings, they are coherent, and the data set is somehow having like similar domains and some other characteristics. So these drastically fail in cases of, let's say, algorithm mismatch or some variation in data, and also some linguistic differences. So later, to come up with better models, some people propose joint training approaches. And the key idea is that rather than relying on independently trained monolingual embeddings, why don't you just train the embeddings jointly? Like you jointly optimize the objective function for the individual embedding spaces. But again, a key limitation was that these approaches, they somehow ignore the impact of semantics. So for that, we introduced graph attention. The key idea is that within each language, there are always some set of words that can be used interchangeably without the change in context. So we just incorporate that impact into the into learning that bilingual isomorphism. So originally, the plan was to learn distributional embeddings and combine them with isomorphism loss. but we changed it to that learn distribution, combined it with isomorphism, but in the middle, there's also a graph attention layer to take care of the semantics. So this is the key idea. So we start from a very naive skipgram, although I plan to extend it to some like very, very sophisticated models, also including LLMs. But this is a very, very like a twice study. So we start from skipgram. Again, in the intermediate, we have graph attention. And on top of the in the end, we combine it with the isomorphism loss. And this is the like the complete model. So formulation, a skipgram is the same, like very basic one from Mikolov. Graph attention, we use like Wilkovic one. Although I do have many other variants for that, but I just kept it to be on like to avoid some tricky questions. Yeah. And on top of it, we combine it with the isomorphism loss. We just try, let's say, L2 and some Procrustes loss. And our combined training objective is combining the distributional and the isomorphism loss. Now, the data and evaluation settings, we have two settings, in-domain and domain mismatch. So for the in-domain settings, we just try to retain the same sort of data for the, that's almost 1 million lines of New Scroll 2020 for Arabic and English. For the domain mismatch, we have English that's coming from the web crawl, and Arabic data is from New Scroll 2020. So we evaluate it on some multilingual data sets that has been already been shared. So, and just similar to the existing models, we use Persian at 1 as the evaluation metric. Now, coming up to the results, so you can see that graph attention can drastically improve the performance. So last 3 rows are some variation of our like GARI. So using L2 and Procrustes, and also so in the middle there's a Procrustes loss with some initialized embeddings. So this is also like performing better than the existing models. Now, lastly, we also looked at some error cases. So if you just look at the error cases without graph attention, that's on the left part. So you see the errors are somehow semantically different from the ground truths. Like, and onto the right side, also they are like doomed to be errors. But the reason for error is that this evaluation metric, that's the Persian at 1, that's not caring for the semantics. So although they are erroneous, but still they're in the right direction. So I think that's it. So any questions, please?
Thank you so much. So we have time for
How do you construct the graph? I didn't get it.
Graph construction, we just follow.
No, I mean, what in relation between words? How do you?
Okay, so graph we follow transductive settings. So the words are nodes, and attention is trying to guide you through the like how much they share the information, how much they share the semantics.
Where do you get this information?
So this is like you can. So firstly, you can just get this information from any pre-trained embeddings, let's say a Word2Vec or some other thing.
Oh, from
yeah.
Okay.
Yeah.
Can the people from the Violet paper come and set up, please? We have time for 1 or 2 more questions. Going once. Okay.
Yes, please.
I guess this is not a method that's strictly limited to English and Arabic, right? Did you try it on other language pairs as well?
Sorry, I missed the last part.
I'm just asking if you tried it for other language pairs.
Yeah, I have another paper for EMNLP this year. So that is for working for Ukrainian and some other, I forgot the language. They're different languages, but Ukrainian and some other languages. So that's part of EMNLP. So core approach is changed because here I'm using the graph attention from Wilkovic, but there I designed the graph attention by myself.
Okay, and just one more question. Where do you see this being applied? Because these kind of papers several years ago were motivated by cross-lingual transfer and such.
So you can just look at the application from even from the, although this is not well from the LLM, but you can transfer knowledge from LLM that is trained into the English into your, let's say, for Arabic LLM maybe. Yeah.
Okay, let's thank the speaker again. Our next speaker is Abdulrahman from MBZ University. And thank you, Asif, for bringing us back on track as far as time is concerned.
Hello, everyone. My name is Abdulrahman, and I'm going to present today Violet, a vision language model for Arabic image captioning with Gemini decoder. This work is in collaboration between UBC and Mohamad-Bassam University. And my co-authors are listed. So why image caption, Arabic image captioning? So Arabic is spoken by 422 million native speakers around the world, and depending on only the translation of the English models is very impractical. Second, like developing a strong Arabic image captioning model can help in developing applications that would help people with visual impairment in the Arab world. And if we look at the literature, we can see that creating a strong image captioning model was always the first step in creating a strong vision language general foundation model. Now for the challenges. Obviously, first, lack of Arabic image and text data sets, which is a huge obstacle in developing a good model. Secondly, since image captioning model consists of an image, a vision encoder, and a language decoder, the suboptimal of the Arabic language models compared to their English counterparts hinders creating a stronger model. And another crucial point is the lack of research in this area compared to the English one. For solving dataset part, we started by translating COCO dataset. COCO dataset is a famous image captioning dataset consists of 123,000 images. Each image has 5 captions and covers only 81 class objects. For translation, we compared the quality of translation of Google Translate and No Language Left Behind. And as highlighted, we noticed that No Language Left Behind had better translations than Google Translate, so we went to that for our translation. But despite the better translation, we noticed instance of hallucination of No Language Left Behind. So to counter this, we filtered the translation over the semantic similarity between the English caption and the Arabic caption, and rejected the similarity, which less than a threshold we put as 0.6. Furthermore, our manual inspection, we noticed that the original dataset had bad captions and typos, and some of them were rejected also by using the same method. Finally, we manually annotated a subset of the test set of COCO we called ARA-COCO, which is 500 images, and each image have 5 captions annotated by a different native Arabic speaker to ensure diversity. All right, as I mentioned before, an image captioning has a visual part and a language part. For the language backbone, we used Jasmine, which is a recent developed Arabic language decoder developed by our lab. And for the vision backbone, we use faster RCNN modification introduced in the bottom-up attention paper. Now for the model. The first part of our model is the vision encoder. We take an image and we pass it to the object detection network to extract the visual features of the possible objects in the image. Then we downsample the features to match the transformer embeddings. We pass these features to a 3-layer transformer encoder to further enhance our visual features. For the text decoder, we split our adjustments into 2 halves, hence the name Gemini. Don't mistake it with a piece of Google. The first half is like a frozen text decoder without any modification and acts as a vanilla decoder. And the second half is a fusion decoder where we put across attention layers in between each adjustment layer. We also, to further enhance the visual features, we use mesh connection, where instead of just taking the final output of the encoder layer, we take a weighted sum of all the encoder layers weighted by the parameters alpha. We also utilize self-resurrecting activation unit gates, which in short block low noisy activations from both self-attention and cross-attention under a certain threshold. And this is our model again for a final look. Now for the results. For our preliminary results, we compare 3 variations of our model with visual GPT outputs. The first variation is just plugging Jasmine with cross extension in all of the layers. We notice a poor performance using this variation, which can be related to the number of parameters of Jasmine, which is 350 million, which makes the optimization problem harder. Then we split the text decoder into 2 halves, but keep the first half trainable. We have found like a substantial increase in performance. And furthermore, when we freeze the text decoder and acts as a vanilla decoder, we found even better performance. We also compare with previous works on the test set of Flickr 8K. As we can see, our CEDAR score is substantially higher than the previous works, although below Plu score lags behind a little bit, but it still matches the exact string similarity, and unlike CEDAR, which compares features, so it's not very suitable for captioning. And finally, we show results on our annotated Aracoco dataset for feature evaluation. Here is some qualitative results. We can see our model can understand the color and the position and the type of the road. Now for the limitation. First, the model depends on with all the models that depends on a visual image detection backbone, it's not end-to-end trainable. And since it's trained only in COCO trained dataset, which covers 281 objects, it has limited word knowledge. And finally, compared to the current English captioning model performance, which is in the 130s, it's still very inadequate and shows mistakes. We are addressing these problems in the future work. All right, so questions?
Thank you so much. So we have time for probably 2 questions. Okay, go ahead.
Sorry, someone who doesn't speak Arabic but is very interested in this field. Can you explain what some of the errors you showed were in terms of qualitative evaluation?
All right, so it says كلب أبيض يمضغ على الأرض, and it's just closing its mouse. It says like it's like chewing, and it just closes the mouse. And the other one, it says like a man wears a white shirt, and it's obviously not white, but there is a white in the background, so it confused it a little bit.
Can I ask a quick question also?
Yeah, sure.
So did you compare to just running an English model, and whatever you get at the output, you just translate into Arabic and then compare to your model?
Yes.
And
yeah,
I mean, what did you get?
Oh yeah, this is the yeah, like our model performed better.
Then translating the output from the English model. Okay, by how much?
Actually, these are by how much?
So which one is so like 56 is the one that you after
Translated,
translation,
and the final one is the one we.
Very nice. Okay, so this would be the last question, and then the next speaker, please come up.
Following on your point, what translation did you use for the visual GPT?
It's the same translator we used for our dataset, no language left behind.
Oh,
to have the same setting.
Okay.
Any other questions? So let's thank the speaker one more time. And can you please proceed? So this is actually the last presentation of the setting of the session, and it's about artists, Arabic text and speech transformers. So and this paper is very, very special because it got the best paper award. So Amir Bik, by all.
Thank you. Good afternoon, everybody. My name is Amir. Today I'll be presenting our first iteration of our project Artist, which stands for the Arabic Text Speech Transformer. This is the first Arabic version of a speech T5 model, and according to our knowledge, the first Arabic model that can do multiple downstream multimodal tasks. So this is the overview of this is the architecture of our model. It might remind you of a speech T5 that we were inspired by. It has 6 auxiliary networks that serve as that serves to tweak the input and output representation to handle speech and text. The main part of the model is the transformer. To be more precise, it has in terms of the number of layers, it has a T5 architecture. And after getting some feedback of our colleagues, the most misunderstood part of our model is the cross-attention, because in that part, we do mixing of a speech and text modality. So before actual transferring the attention values, we quantize we quantize speech and text values in a batch. So to be more precise, only 10% of a text and speech modality is swapped in a time step dimension. As for pre-training, we have used MGB2 dataset, which has a more than 1,200 hours of collected speech data. For the speech, we use the TV recordings that it has, and for the text, we used the transcriptions. One remark that speech and text doesn't have to be aligned, so we use transcription just because it was easier to do. We have done some pre-processing, like few standard pre-processing. For the text, you may see we've removed some punctuations, and except for the special symbols. And for the speech, we have done we changed the sampling rate. You may see the example of pre-processing on the slide. And for the labels, we used tokenized version of the text, and for the speech, we used Hubert labels. The details on the slide, but in short, we have used English Hubert on, to be more precise, ninth layer of the Hubert. We take them as a discrete value. We take discrete values from the ninth layer. We did clustering. We clustered them in 500 classes, and the centroids of the classes were used as the discrete labels. So after pre-training, we can do fine-tuning. So the first task that we've done is just ASR to test our model ability. As you may see, we have activated some part of the model and pruned the other. So we have conducted some preliminary analysis and experiment with the speech T5 model, which is an English-based model. Since Arabic and English have a different vocabulary length, so we've extended the speech T5's tokenizer to incorporate Arabic text, Arabic letters and symbols. And then furthermore, to work with that tokenizer, we extended the input embedding. We have randomly initialized new values. Oops. Nope. So here we have two experiments with speech T5, which has a original Arabic script and backward representation. I would like to bring your attention to the result on MGB2 and QRTTS, especially WER and CER are good, and CER is very good. This proves that even English-based model that was fine-tuned on Arabic still can process Arabic speech. And nonetheless, Arabic pre-training outperform all results. Then we have placed our model artists and compared our result with other state-of-the-art model on the MGB2 dataset. As you may see, we have two versions of artists. The first one is just the artist without language model. We have detokenized the output of the text postnet decoder. And for the artist plus LAM, we have trained a decoder-only model and fused them to artists using the same procedure as it is in the state-of-the-art model that we have placed here. We have also evaluated our model with a data set that were not used during the training. You may call it as a zero-shot evaluation. We also compared them with other multilingual large models. As you may see, our model outperformed all of them. This is the common mistake of the model, which might not be considered as a mistake, because as you see from the example, our model predicts English letter instead of Arabic, but in fact it is like English in Arabic. And there are some mistakes from annotators. They don't include this. They don't put the right transcription. They just might skip them, but our model still can like handle with this. The next task that we have work on is a TTS. Again, we have pruned and activated only necessary network. And at first we introduced the baseline again, speech T5. The algorithm to work with Arabic with speech T5 I already explained to you before, but this is like what we have done. Also, we have used speaker embedding to make model work with multiple speakers. MOS results for the baseline is poor, but the result but MOS for the artist is better, which proves that pre-training matters, like what data used for the pre-training. And finally, we have also evaluated our model in a Arabic dialect identification task. It has the same setup as a ASR, but instead of text decoder, text embedding table, we have used dialect embedding table. So even though artist wasn't pre-trained with Arabic dialect, except for the 5 that is in a LGB2, model achieved state of the art, at least outperformed. So we have some future work that we would like to work on. We have now discovered this text-to-text and speech-to-speech application, such as speech-to-speech translation or voice conversion. Also, we didn't use dialect in the pre-training, which we will do in our second iteration or later works. So because now we have MGB5 that has 17 speech, which is like good. And lastly, we'd like also work on the multilinguality, at least to understand code switch data. So we have some demo. You may just scan the QR code and try yourself. If you have any feedback or question, you may just drop your email to any of us. And thank you.
Thank you, Amir. We have time for probably 2 or 3 questions. Yes, Faris.
Thank you very much for your presentation. I just want to ask about I have noticed that you included the numeric characters or digits as one of your labels. Why didn't you use inverse text normalization instead?
I don't know, we just started with the standard approaches and apparently it works, so we didn't spend much time on this. We were more considerate about the task, what the model can do. It's like trade-off of time.
Okay. Other questions?
This one?
Yeah, it's spoken or?
Yeah, this is ADI 17 challenge task, which is from MGB5. It is speech, okay. So it's I think it answers your question.
Okay. Any other questions? You seem like you want to ask a question. Is that true? No? Okay. I thought you raised your hand. Okay. If there are no more other questions, thank you all. And thank you, Amir, for a nice presentation. And we'll meet after. Yeah.
If you are presenting after lunch, please make sure to send me the slides so I can have you set up really quickly.
How are you? Oh, right. No, it is.
Yeah, you can press it. Sure. Okay.
Do you have it?
Welcome back, everyone. I hope you have a good lunch. So we are back with this session. We have 2 talks for the long papers initially, then we'll be followed by 5 short talks about the shared tasks. And then actually for the panel discussion that I think everyone would be excited about it. So we are back with the first paper about Salma. Mustafa will talk to us about Salma, Arabic sense annotation corpus and word sense disambiguation benchmarks. Okay, go.
Well, who is Salma? Why Salma? You know, I was hoping that I have a daughter, but she never came. I don't have daughters, but I always wanted to name her Salma. So, and by the way, and sorry, you are Salma. Oh, but I gave the name to my brother, so we have Salma at home. And I actually, this paper, I myself consider it my best work because it's very hard to do. So you will see. Before starting, again, you can scan to go to the semantic analyzer or word sense disambiguation and try it yourself. It's working. So I will make an introduction because I know this community is not really familiar with the problem of word sense disambiguation. Okay, so let me just take your attention 2 minutes to give introduction about this work, the state of the art in this work, before presenting our work. So there are 3 downstreaming tasks. One is called WSD, one is called TSV, and another one is called WIC. Okay, 3 tasks related to semantic understanding. The first one, WSD, given a context and the word in this context, and we want to know which meaning is the correct meaning for this word, which sense. This is called WSD. Okay, so it means you have the senses with you. The second one is called TSV, is related, given context and given a gloss definition or a sense. So we classify it true or false, whether this meaning is correct with this. It's called TSV. Okay, and the third one is called WIC, given 2 sentences with a shared word between them, like here jadawil. I would call it shared lama if you like. Bijadawil al-jadawil. So the same word in 2 sentences. We want to know whether the 2 sentences, the 2 words in these 2 sentences have the same meaning or not. So this is a true and this is false. Okay, these are 3 known tasks in WSD. So Now, my paper is going to be, so we developed a data set, corpus, with sense-annotated corpus. Every word in this corpus is annotated with a sense, with actually even more. And this is one thing. So the corpus is 34,000 tokens. It's actually part of Wujud, the text itself. We annotated with two sense inventories, two sets of meanings in parallel. And we also annotated with named entities. Even it's part of Wujud, but if you work in WSD, you need special issues. So we did this. And Salma system is the one that makes WSD. So we have Salma system and Salma corpus and the Salma baselines. Oh, sorry. Okay. So this is the tool we use to annotate. If you want to take the tool, also it's open. So this is a sentence. It's batch. So the tool, if you click on a siyasa, you get all context that include this word with different forms. السياسة, السياسات, سياسة, سياسات, وإلى آخره. So we here the meaning is this one. So مباشرة, السياسة, سلوك الحكومة. This is a gloss. So these are the set of glosses, and we annotate. We say that السياسة, this is the direct meaning. The direct meaning. But there is also معنى عام, general meaning. So, but to make it simple, we link it with this one. So this, I'm using the pointer, but it's not. So this meaning, معنى المباشر, is actually used in these sentences. Okay. The details are in the paper, please, so I will not go. These are statistics about the work we did, the functional words or verbs, nouns, so different type of things. Oh, we have 2 minutes. So please look at this. That's very important figure. So how it works. So given this sentence, كيف ساهمت السياسة الأمريكية المستندة, we want to know which meaning of السياسة. So what we do, first we lematize. We know the lemma. Then we look up the glosses. So السياسة have 2 meanings over there, gloss 1 and gloss 2. Then we combine the two glosses with the same sentence. Okay? Then we ask the TSV model. We actually, our innovation is TSV models that we published in another paper. And so we get here the logits, as you see the true logit. So this one, 7, for example, is more probable that this is their correct gloss. Okay. We did it with, we actually used in the system 3 TSV models. The last 2 was developed by us, and the first one was developed by somebody called the Razaz. I have 1 minute. And so, well, with the sense inventory modern, we get 84.2%. This is really, really high. Just to let you know that in English, there is 80 with WSD. So, and we are talking about full Arabic, not only a small set of senses. We are talking about something 60 something definitions. So we are talking, yeah. So okay. So you can try here. So قصيدة من عيون الشعر. These are the meanings. So العيون, عيون أجود كل شيء وأحسنه. This is one meaning. If you try it in another sentence, صورة العيون جميلة. So عيون means an eye here. So you can try أعمل في جامعة بير زيت. You can try. It's, by the way, it includes also named entity recognition. So we know we have full analysis, full semantic analysis for everything. On time, right? Perfect. Okay.
So I think we have the time for one or two questions.
Or suggestions.
Or suggestions. Yeah.
I may have missed it. Thanks, Mustafa. Can you say a few words about the annotation process that was used for the senses and the inter-annotator agreement level?
So for the annotations, here, you see, take this sentence. كيف سوري واقع فوضوي كهذا سيجعل السياسة أكثر صعوبة. What does it mean السياسة? So if you ask me what are the meaning of a سياسة, these are the set of meanings of a سياسة. Okay, so the most correct one is this one. But our corpus, not we did more than other corpora for other languages. We annotated all senses. But with degrees, the highest one is this one, مباشرة. So this is the most correct one. Least is this one, مبادئ معتمدة تتخذ إجراءات. So we did the morphological the senses, you see, with we annotated all senses for everywhere.
But still, when two people do the task, what is the degree of difference in the ranking between, because this
Oh yeah, so the inter-annotator agreement, actually I didn't include it just because these are details, but we compared it with quadratic kappa. So it's weighted kappa, not the normal kappa. Okay. It has special measures. We did it quadratic and linear kappa. Yeah, it has some formula for this. It's called weighted kappa.
So what were the results?
The results is actually high because of the training we did for it was done by 3 linguists. It's all details are no paper. And we compare with 2 dictionaries. So one of them, modern, is really higher than another one because the definitions are better.
Okay, thanks. I think we are out of time, so I'll speak again. And now I think we have Camel Parser 2. So Ahmed. So that would be interesting. I think everyone knows Camel Parser, not the camel, Camel Parser. So version 2 here is ready. Exactly. You should try it on WSD and see.
Hi, everyone. My name is Ahmed El-Shabrawi. I'm very happy to present our work on Camel Parser 2.0, work that was done by me and my colleagues, Mohamad-Bassam, Go Inoue, and Nizar Habash. First, a little background on dependency parsing. Dependency parsing takes a sequence of words, for example, the sentence, وَهَلْ سَيَشْرَحُونَهَا, meaning, and will they explain it? It takes the sentence and analyzes the grammatical structure by identifying the binary relationships between words. An example is yashrahun and ha. Yashrahun means they explain, ha means it. Ha modifies yashrahun by being its object. Some motivation on why we use parsing. Parsing gives you a deep understanding of syntactic structure, which still remains very valuable in many tasks in NLP. Some recent applications include being used in the analysis of LLMs, guided data augmentation, semantic role labeling, and grammatical error correction. In terms of work that's been done on dependency parsing, lots of people have proposed architectures for dependency parsing in recent years. One that stands out is the bi-affine attention model. That it's a graph-based neural model It's achieved state-of-the-art or near state-of-the-art results in many languages, but it's untested in Arabic. In terms of publicly available parsers for Arabic, there are two that stand out: Camel Parser 1.0, which is SVM based, it's not neural, and it's trained for the Katib formalism. And a formalism, just to give you a little background, is a set of annotation rules, basically how we make those dependency trees. And UDPipe 2 is available for the universal dependencies formalism, but it's trained on limited Arabic data in terms of, and by limited I mean much more in the realms of the annotated tree banks have been made since then. So in summary, our main contribution is creating Camel Parser 2.0, which is a state-of-the-art dependency parser. It can work with raw text in this pipeline. And this is our main contribution. First, go quickly through the pipeline. Starts out with input processing. We do normalization, diacritic removal, and simple word tokenization or white space tokenization. We then pass this output to a morphological disambiguator to get syntactic tokens, part of speech, and morphological features, where we only use the tokens as input to our parser. And our parser is based on the bi-affine attention model and leverages contextualized word embeddings from BERT. And we use CamelBERT models as well as ArabBERT models to generate these contextualized embeddings. And then eventually our parser outputs the labels and edges of the dependency tree. And finally, we combine everything into a Conal X or Conal U file. The difference being X is for the Katib formalism, Conal U is for the UD formalism, universal dependencies. And we combine everything in a well-formatted output file. In terms of evaluation, we evaluate on both Katib and UD data. For Katib, we use the Pan-Arabic tree bank, which is MSA News. Camel Tree Bank, which is a multi-genre corpus and contains everything from pre-Islamic poetry to online commentaries. For UD, the data that's available is the Prague Arabic Dependency Tree Bank, which is MSA News, and Nudar, which is a UD, a UD version, so to speak, of the PATB, and it's MSA News. The experiments we carry out to determine the design of our parser mainly we report on the labeled attachment score, LAS, which is the percentage of tokens that have a correct head or parent and the correct label with that relation. And another novel contribution is that we report on both gold and predicted tokenization, and there is a difference due to of course, predicted tokenization is not perfect, so it's important to know what those numbers look like. We compare different training data configurations. We use different BERT models, pre-trained BERT models for the embeddings, and we compare our system in UD. So just a quick look at our experiments. We do some baseline testing. We find that our system achieves a 46.3% error reduction compared to the previous system, Camel Parser 1.0. We also compare with other work, but for example, Kankan and Pati et al. Don't release a parser. They just do experiments. We do experiments to look at the BERT choice model. We find that the choice of the BERT model has a significant impact on parsing performance. ArabBERT has the highest performance, as you can see. However, on CA corpora, so when we test on classical Arabic corpora, it's important to use CamelBERT CA because there is a significant difference. On the subcorpus level, we don't really see a statistically significant difference between CamelBERT MSA and ArabBERT, but we'll make both models available for usage. And we see similar trends in predicted tokenization, but of course with lower numbers because tokenization greatly affects the parsing performance. And we do the same thing with the UD data that we have access to. We achieve the state of the art compared to all the other previous systems or other work that's been done. And we observe that in this case, CamelBERT MSA actually outperforms ArabBERT. So in conclusion, we have created a state-of-the-art Arabic dependency parser. We will release our open source Python code. We have already released it. You can access it right now through the QR code. We plan to continue to support and enhance Camel Parser 2.0, and we plan to add support for dialectal Arabic in the future. Thank you for listening, and I'd love to hear if anyone has any questions.
So we have a time for a couple of questions. Yeah.
Yeah, I was planning to ask about the dialectal support, but you said it's future work. But can you comment maybe how it will be? What is the difference? What is the needed? What is?
Yeah, sure.
Because the prefixes and suffixes are so rich in dialects.
Yeah, so there's an issue with dialectal Arabic, of course, being the data availability, and the data that's available needs to be converted from constituency to dependency, and work on that is very well. I don't think anyone's been doing work on that and combining all the dialectal data that's available, annotated for dependency parsing. We're working on it right now, and there are things where there's a great transfer between MSA and DA, but we're still looking into that, and we want to create a strong model for DA. We don't want to release something that's just hacky or something. We want to do proper research.
Maybe I can follow up a little bit more. So whatever he said is true. He's actually working on it. I think so the issue is the resources that are created. The LDC had some tree banks for Egyptian Arabic. There's a Levantine tree bank also that was created almost 20 years ago, has not been used since then. And there's also a Gulf Arabic currently being prepared to be published this coming year. So, and they're all in the dependency representations, can be converted to dependency representations. Your question about the prefixes and suffixes, actually there's a huge overlap between the transfer, as Ahmed said, is actually high. Some things, if you take them to the part of speech level, you could actually learn, like, future particle could be ha or sa or gha or whatever. If you know that it's a future particle, then you know how to behave to use it. So I don't think it's actually a problem of the syntax per se, but it's also the transition from surface words, disambiguation, as you know, because you've worked on that, all the way to the deeper levels. And it has never been actually properly tested, so we don't have exact numbers yet. Yeah.
Okay, thanks. I think if there is more questions, can be in the coffee break, because we are running a little bit behind schedule. So thanks so much.
Thank you. Thank you.
So now it's the time with the shared tasks talks. The first one is the persuasion techniques and disinformation. Do we have someone to present this? Oh, for
Do you have slides? Can you share them? You emailed it? Oh, it's not. Oh, you already put it. Oh, wow. Oh, right here. Nice.
So the talk would be around 3 minutes. So enough time to read your title. So.
Hello everyone. Thank you for joining the talk. And I might have to be very quick, but we have a poster session. If you have any question, please join over there and ask as many questions as you want. So, okay. This is our shared task arrival, shared task on persuasion technique and disinformation detection in Arabic text. So I am Firoz Alam from KSAA-RD, and we have the colleague from MBJ, University of Padova, University of Trento, SBQ. So this year, following up the work from previous year, this year we proposed 2 shared tasks. One is persuasion technique detection, another one is disinformation detection. And in terms of persuasion technique, it's a way of communication that deliberately represent symbol appealing to emotion, prejudice, and bypassing rational thoughts to influence its audience towards a specific goal, either to attain or any political agenda or economic agenda. So this here we actually propose 2 subtasks under persuasion technique. Given that there's a tweet and news paragraph from news article, categorize it into 2 different levels, propagandistic or not propagandistic. And another one is multi-level. We have for each news paragraph, we have more than 1 level. And then the task is identify 0 or more of the 22 techniques we annotate in the data set. So in terms of data, we have some data set from last year, and we also annotated data this year. It consists of tweets and news paragraph. The news paragraph part is completely new, which we annotated this year. Again, it consists of 23 techniques. For the data annotation, I will skip this one. Like we actually go through 2 different phases of annotation. And we have like total 3,000 tweets and news paragraph, and consisting of around 5,000 annotations. For disinformation detection, again, we have 2 different subtasks, binary classification and multi-class classification. And in terms of data, again, this is interesting. Maybe I can discuss during the poster session how we actually collected the data set. And in terms of like 2 subtasks, there are different level of distribution and sizes. Okay, so again here, this part is interesting. So we run it in 2 different phases to make sure that participants actually participate in development phase and test phase. And in both tasks, we had 20 teams participated, and we had 16 system description paper. In terms of approaches, again, this is commonly we see fine-tuning most of the transformer model and ensemble data augmentation. These are common approaches in different subtasks. In terms of performance, in different subtasks, we see different kind of levels. Performances for simpler tasks, mostly binary tasks, performance are typically higher than multi-level tasks. You will see in both subtasks like task 1 and 2, a similar pattern. So in terms of findings, what we observe is that several participating systems showed positive impact on exploring different kind of loss functions other than like using typical cross entropy loss. And for disinformation detection, we see that like similarly, the performance is significantly higher for like simpler subtasks. Okay, so basically, okay, the summary is we had 2 subtasks this year consisting of tweets and news paragraphs, focusing on persuasion technique and disinformation. And we are thinking of to offer it next year, but with more granularity, multimodality, and maybe at the SN level. We'd like to thank you, KSAA-RD, for the support with grant. Thank you.
Thanks a lot. No, that's perfect. Thanks. Actually, there will be no questions for shared tasks because there will be a poster anyway, and you can see the overview poster and all the shared task posters as well. So the second one is for Nadi. I think everyone knows nuanced Arabic dialect identification task running for the first time this year. Yeah.
Assalamu alaikum. Okay, so my name is Mohamad-Bassam, and I'm going to present this shared task on behalf of myself and my colleagues here, Abdul-Rahim Al-Madani, Mu'taz Billah Najudi, Huda Abu Amr, and Nizar Habash. We're running this shared task, I think, for the 4th year in a row. And I will quickly just walk you through what is happening. So if you haven't seen the shared task before, it's just about Arabic dialect identification. And we started also kind of looking into other Arabic dialect processing. So in 2020, we started on like, country level and province level dialect ID. And then we added one more task in 2021, 2022, we added dialectal sentiment analysis. This year, we do the same thing for dialect ID at the country level, but we also started introducing dialect to MSA machine translation. And we had 2 tracks on this, one open track and one closed track. So the first subtask focused on dialect ID, and we provided some new Twitter data sets. And also we allowed people to use existing data sets from previous years from the shared task. And this subtask is a closed track, meaning people can only use the data we provided. And some distribution of the data. Subtask 2 is closed dialect to MSA machine translation, focusing on 4 dialects where we actually prepared new data sets, but only for development and test. We didn't provide any data for training the machine translation task, but we allowed people to use the Madar existing data set, and we didn't allow them to use any other external data for this. We wanted people to experiment with methods to work under limited amounts of data. But subtask 3 allowed people to do that. They can develop their own data sets or like use our other methods and so on to augment the data. The data the shared task was popular, so we get lots of people registering, 58 unique teams, and then lots of people scored their systems and so on, as you can see here, and we got 13 papers published out of this. There's a description in the paper about the different methods people have used and so on, and we typically did an in-depth analysis of these methods, and we show also the results. This talks about the evaluation metrics and the baselines and so on, and the winning team there. And this is about subtasks 2 and 3, same thing. I think it's interesting to see what methods people used for each of these. So I invite you actually to read the paper or talk to me. So I'm happy to discuss. With that, I just wanted to emphasize that this continues to be a challenging area of work, and we intend to continue working on this, and we're happy that the community is engaged. That's it.
Thanks a lot. That looks really exciting. So we are looking for the poster session to get more information. And I think Mustafa, the wujud, we heard about several times in your presentation. Now know the details about wujud, but in 3 minutes again.
So wujud shared task is actually, as you can imagine, So we actually collaborated on this shared task with my team and Muhammad Abdul-Mageed's team. As you see, we have 7 people. So what we did actually, we shared the wujud dataset. We have splitting that is not the same as the paper, the original paper of wujud. So we made different splittings. So it means different results, of course. So the splittings, we share it. So wujud is about 500,000 tokens, very rich, 2 subtasks. One is called flat named entities, and the other one is called nested named entities. As you see here, مؤسسة إدوارد سعيد Foundation is organization in the first task, only organization. But in the second, there are 2 entities. One is the organization of the organization, and the other one is Edward Said himself is a person. So 2 subtasks. So as you know, or may know that wujud is actually a very fine-grained and rich corpus. It includes 21 kind of entity types. And by the way, it's also include the dialect, not only MSA, and so on. So we made the splitting, we share it, we get 45 unique teams who registered, and then 11 participated in the flat subtask and 8 in the nested subtask. These are the names. الإسكندرية University, 2 teams, زرتال, الخوارف, العياداتا, well, you can read it yourself, Fraunhofer, and so on. So as you see here, the baseline, so this is the results of task 1, flat near. So many people actually did much more than the baseline. So we computed the baseline 90% accuracy with the R-paired and 88 with Arab-paired. So 2 baselines, but many teams did more. The highest was 91.3. So with the nested near, as you see here, the somebody achieved 93 point, almost half. This is actually a high number. What makes it actually, even with person, organization, and so on, they are really high. But like event is very difficult named entity. Very difficult. So it lowers. So some entities lower the results, but the known ones are simple and high. And as you see, the nested is higher than the flat. So that's it. And I invite you to talk with the authors of these papers.
Thanks a lot. Again, the poster will be available with all the details and the short tasks as well. The next one is the Arabic Reverse Dictionary shared task. We have Rawan. Yeah.
Okay, Assalamu alaikum wa rahmatullahi wa barakatuh. Hello, everyone. Today we will present the KSAA-RD shared task, the Arabic Reverse Dictionary. We are from King Salman Global Academy. The author of this shared task, me, Mohamad-Bassam, my colleague Walid al-Shammari, Dr. Abdul-Rahman al-Saimi, Dr. Afrah Tamimi, and the other team, Asma al-Widra, Hala al-Harbi, and Dr. Abdullah al-Fifi, and Dr. Sarah Hammouda. So the shared task actually is to solve a simple problem with our mind, but it's difficult for the computers. Sometimes you know a definition of a word, but you forget the word itself, either the definition in English or in Arabic. So the task was to find the word for an Arabic or English definition. So for example, if the definition is al-masir laylan in Arabic, so the word is al-isra, and in English, traveling at night, and it's the same word. So we divided to 2 tasks, the Arabic Reverse Dictionary and the Cross-Lingual Reverse Dictionary. So for the data, there's the Arabic Language Dictionary by Ahmed Umar Mukhtar. Our annotators take it and annotate it and do another version in the LMF style. And for the English dictionary, there is in the same eval the last year, 2022, there was the same task for 6 languages, but the Arabic was not none of them. So then we did a manual annotation for the Arabic and reverse dictionary. For the Arabic and the English dictionaries to have annotated dictionary for this task. So the data were in 2 embeddings, the Electra and Skibogram Word2Vec, to use them in the tasks. They were in this style. So it has the ID, the word, the gloss, POS, Electra, Skibogram, and the ID. For the Arabic Reverse Dictionary, we have 45 for training, 64 for development, 6,400 for the development, and 6,400 for the testing. And for the CLRD data, the statistics are there.
Hello, everyone. For the model and the evaluation metric, for the model, we use a straightforward transformer. The input was a gloss definition, and the output was embedding. For the evaluation metric, we have been used 3 evaluation metric: the mean squared error, the cosine similarity, and the ranking metric that have been proposed by MECAS, which is the semi-eval paper of 2022. For the team, the participant team, we have received 31 unique registration and 39 valid submission, and 5 unique team were received. Thus the team. For the result, 3 team have been utilized a birth-based model for both tasks. We noticed that also the UWB team have been used a rule-based model that based on dictionary, and it achieved a very good performance. Also, Ross-Traston team, which is the winning team, have been utilized in simple BERT model. Exactly, the best in simple was Camel BERT and Mara BERT version 2. As you can see here, the result. For Abed team, they have been achieved a very good performance, and they use the data manipulation technique, which reflect the importance of the data manipulation technique for this task. For the winning team, Rostaston team achieved the best team for both tasks. The second best team was for the RD task is Qamusi, and for the SLRD task was Abed, and the third best team was UWB for both tasks. What is next? We start to do the reverse dictionary for Riyadh dictionary, which is Mu'jam Riyadh, that recently been released by King Salman Global Academy. And we adopted this field for this shared task, and we invite the community to participate in this field. Here you can find the code and the data for the shared task. Thank you.